If you question whether or not I'm here for truth, question if I was a real flat earther or not. The reality of it is there are no flat earthers. There are only globe deniers. Every flat earth evidence really is just a globe phenomenon, explained by the globe. Don't you see? See, I'm still here for truth. Now there are certain people in my way. Deny evidence. Flat Earth, you ask a lot of questions. It's time to answer some now. What is up, people? So, it's going to be a fun day, but I got something to say. Before we start anything, I want to make this very, very clear. Something was said to me in the other hangout while Jose was going on, and I can't let it slide, and I wasn't gonna. I tried to actually say something and got talked over, but Chris, do not ever in your life question my parenting abilities, ever in your life. If I question your knowledge about refraction, you will never in your life, ever in your life, listen to me, ever in your life, Chris, question my parenting skills. You don't have to say thank. You don't have to say sorry or nothing. Just don't make that mistake again. Because I'm letting you know now, Chris. Do it again. It's a threat. I'm going to threaten you. Do not do that again. Period. We're done. We don't have to fucking talk about it. You don't have to apologize. Nothing. Just do not do it again. But with that said, guys, I'm in a good mood today. I made sure that I'm going to stay on the topic at hand. The main thing I needed to do is I need to make sure had someone here whose memory doesn't go short term every once in a while, and really wanted to get this topic done. So Barney's here. We're gonna really gonna tackle this. Um, Chris, you said you want to present something. Um, how long is this presentation of something? And if you want to go that route, Chris, we don't have to have a conversation at all anymore because all you're going to do is trigger me, and that's not going to get us anywhere. So, since you don't seem to be the mature one about it, I'm going to go ahead and just bypass that and go ahead and say, I guess, present on your own channel because I gave you that opportunity. But like I said, I want to go over this stuff anyway, and this is far more important than a Chris Berry experiment. I'm pulling up my little cheat sheet that I got. Right, so Yeah, hey Chris. I mean, I'll let you present something, man. But I just want to make sure you understand where what I'm talking about, so that you don't do something stupid like you did. Um, Here's what I'm gonna do. You know he's a flat earther, right, Merle? um, what I'm gonna do is, hey, Chris, I'm gonna give you the link in the Skype. I love when two flat earthers fight. It brings a tear to my eye. Where is? Yeah, I'm gonna put that link in the Skype. Make my life easier for right now, just so that you don't have to get talked over, and and Barney can make sure we keep on track today, because he's been doing a terrible job the past 2 days. You in here? Where the fuck? I know you're in one of these little discussion things. There you are. Got so many damn aliases, man. What's wrong with you? Just kidding. You have like the fucking same name on everything. All right, the hangouts and the Skype. Again, Chris, I gave you the warning. Do not don't push me. But anyway, until he gets here, we'll look at this. All right.
Yeah, you got me.
All right. What's up? What?
Okay, so
Hmm?
I gotta do me.
No, you're good. Go ahead.
All right, so oh man, I was just goofing around earlier looking over some definitions of refraction, and I just can't believe that I've missed this for so long. And you listen to people like Rumpus, Dean, who claims to be an expert on light and refraction and 3D graphics, and then George Natchik. And I've made videos in the past where talking about refraction can cause things to magnify and to cause objects that are further than they look to appear closer, if that makes sense. So like, when you see something and you see a for example a turbine that's cut in half, um, it's 20 miles away. Well, it's not really that far. It looks much closer than that. And Barney, what the hell are you doing, man?
I'm showing you how refraction can make things magnify.
There you go. Right. Well, I'm glad, and in fact, I'm glad Barney's on because I'd like his take on this. So let me just present.
You remember what happened last time you said that, right?
That I said what?
Last time you said, "I'm happy Barney's here. He's a voice of reason." And then he went against everything you said, and he went, "Well, I guess Barney's not as smart as I thought he was."
No, that's not true. I never said that.
I was here. I was sitting right here. I was here.
Well, I didn't. No, I didn't say he wasn't as smart as whatever.
Oh no, yeah, you did.
All right. Well, anyways, so let me share my screen and let me show you what I found. So, and the reason I said I'm sort of upset even at myself is because these things I found are in the basic definition of the term looming. Okay, so Rumpus has hijacked looming, and he's saying that looming is the reason we're seeing things over the curve. Au contraire, Rumpus, looming is the reason things are hidden. Come on, Sean. Give me a couple minutes here.
Okay. No, my bad. I was reading something in the chat. My bad. I do apologize.
Oh, okay.
I didn't rouse up on the mic again.
All right. So Rumpus has hijacked looming as the reason for why we see things over the curve. Looming, based on the actual definition, which again I just can't believe I had never really looked at the definition. I was going off of the word of Rumpus and Dean and George, and then let's take a look at it. There's a looming from Wiki, and I'll have another source here in a minute. There's a different type of mirage that is also described as looming, in which distant objects appear much nearer than they actually are. Wow. So the claim that refraction can't make objects appear closer than they are is false. is explained in the same way as the image of the ship, except the image is not inverted. So with looming, they're saying there's no inversion. Fine. The density variations may also act as a magnifying glass. People, this is huge.
Why'd you read it like that? That was weird.
Because I'm emphasizing it. This is huge.
I was emphasizing?
Dean, yes.
That was good.
Dean,
we're going to work on that one,
Rumpus,
buddy.
and George. It's a robot emphasis.
Okay. Oh, then it was perfect.
Wait, Chris.
Dean, Rumpus, and George have denied this. I have them on video denying it. I have them in Skype chats denying it. It's
really
right here in black and white. Well, because they called me stupid and that it was impossible for this to happen in the atmosphere. And it's right here in black and white. Barney, go ahead.
Yes. When you look at that page and read the first sentence of it, what is it talking about?
This sentence?
Yes.
It's just saying that the word looming has multiple definitions. And obviously, right, many words have multiple meanings. This is talking about something to do with psychology.
Yes. So, and there is also a type of mirage or optical distortion. That's your point. And there is a link up there which says, and I see you've clicked that link, so it's not that you haven't noticed it.
It's my next page.
Okay.
It's this page. It's the next thing I was going to. Okay. Barney, man, I'm glad you're here. Check this out.
Aren't we all?
Looming. Okay. So basically, Rumpus is claiming anytime we see things too far, he's claiming looming, no matter the conditions, no matter if it's in Florida or Great Britain or Australia or wherever the hell. Okay. Listen to this. Looming is most commonly seen in the polar regions. Wow. How many observations have you seen in the polar regions by these people? Looming was sometimes responsible for the errors made by polar explorer, for example, Charles Wilkes, charted the coast of Antarctica where later only water was found. Okay, so this is telling you that the most likely conditions where you'll see this type of looming is the polar regions.
Yes.
How does that
contradict Rumpus?
Wait, Chris, is this
over a curve?
Are you debunking Rumpus or are you trying to debunk the globe? It matters.
Well, okay, that's simple. That's fair. I'm debunking Rumpus.
Okay, cool.
Okay,
just want to make sure. Cool.
Well, this third side, or whatever you call it, is just a reiteration of the wiki. So if you didn't like the wiki source, and here's a different source with the same definition or whatever, the same word. So I don't know if wiki got this from them or they got this from wiki. But either way, so when you look at so when you're looking at, Rob Skiba, and he's doing his, because here's the other thing is everyone's saying, well, you can't use a Fresnel lens because it's a magnifying glass. Well, we just read, right, that the density variations may act as a magnifying glass. So yes, we can.
Yeah, but it didn't say Fresnel lens.
Well, a Fresnel lens is a type of magnifying glass.
Yeah, but it's a very distinct type. It didn't give you a description that you can use one to depict anything. It was just saying. Things act as.
Well, it says the density variations may act as a magnifying glass. A Fresnel lens is a type of magnifying glass. It doesn't say. It's not going to tell you list every type you can and can't use.
I'm just letting you know it's not the same. You're using it.
How am I using it wrong?
How do I say that? Like, I see, like, you're trying to pinpoint it. Like, you can use a Fresnel lens to answer things, I think, is how I'm interpreting it. But again, you would have to make that up, that to show anything, you would have to have 100 different lenses to act, to be changing the variable. You couldn't just use one. Not even just one Fresnel lens.
No, that's not what this said. You just
I didn't read off that. I'm just letting you know that when we
you're making claims that you don't have any proof for. Why would you need 100 lenses?
Whoa. Dude, no, because I'm telling you now. So there's only one type of looming. Like, one thing happens with looming is what I mean to say. There's an observation of looming, and it does not vary, and it only happens at this one time. Is that how it works?
No, that's called a straw man. I just read you the definition.
No. It's not a straw man because it's not.
It is, Sean.
Okay, no, it's not.
I just read you the definition, and now you're going off on things that I didn't say.
Because you keep making. I said this on Jose's panel a minute ago, or a little while ago. The problem is that you're trying to set up a scenario where the atmosphere is an explanation for what we see, and you keep forgetting that currents, oceans, and atmosphere and weather, like all these things, differ. They change everywhere, all the time. Period. But obstruction still happens the same way every time, and that's like a huge disconnect right now with this whole fucking obstruction.
Wait, let's get to his point, right? Let's see what he's trying to. Let him debunk Rumpus on looming.
And do a good job, because I don't like Rumpus.
Well, I mean, Barney, I just did it. Like, I just read you the definition of looming. It didn't say it causes things to come up over the curve from 40 kilometers away. It said that it did two things. It can magnify things, and it can make things appear closer than they are from the distance that they are. And that's exactly what we see in someone like Rob Skiba using a Fresnel lens to, again, I'm not saying it's perfect, I'm not saying it's an accurate 100% representation, but to represent the atmosphere, you need something, right? And the best thing that people have found so far is, I guess, a Fresnel lens. And when he uses the Fresnel lens, it pulls the object closer to call it the camera from where it is. It covers the bottom part of the town, and it mimics a lot of these observations that we see. That's all I'm saying. And then Rumpus says that, well, no, looming is showing things, when the definition I just read said looming is causing those things to, or potentially causing those things to be hidden because it's pulling them closer than they are.
You know what potential is? Looming isn't law. Like, do you see what I did there, Barney? I said it wasn't like a law. Get it? Because it changes. That was a joke, people. Sorry. Okay, so your definition of it, I'm trying to like follow along with what you're saying.
It's not my definition, but
no, well, that's the thing, because I'm looking at it, but I can tell you're jumping around. So
I was on one source. How did I jump around?
Because how do I say it? Like, you read something, but you're like the 40 feet of distance or 40-mile distance. Like, you're adding things that make it so it doesn't even make sense. So you're saying that? Okay, wait. What did Rumpus say?
Okay, wait.
Maybe that's what I'm confused about. Go ahead.
Yeah, I'm also slightly confused on what you think you're saying here. So I'm looking at the wiki page, the second one, looming and similar refraction phenomena, which is talking about the atmospheric effects. Looming is the most noticeable and often observed of these refraction phenomena. It is an abnormally large refraction of the object that increases the apparent elevation of distant objects and sometimes allows an observer to see objects that are located below the horizon under normal conditions. Now, I never understood Rumpus as saying anything other than that.
I just want to say, Loken16, hey man, I appreciate the shit out of that, man.
Well, that is what he said.
Okay. So what's your contention?
The contention is he's not saying the other part, which is it's causing the object to appear closer than it is, which can cut it off, as we've seen in many observations, including red pills, and it's potentially magnifying it in the whatever it said. Let me read it to be specific. The density variations may also act as a magnifying glass. And I still have people in the chat right now saying that I'm an idiot for saying that. Well, I'm just reading off of the definition. Like, I don't know what else to tell you.
Chris, I can make a suggestion.
Okay, so
don't watch the chat.
Fair enough.
Now, I do not find contention with the statement that the density variations may also act as a magnifying glass, nor as any other kind of lens. If the shape of the lens is concave or convex, you will get magnification, or what's the opposite, the diminishing scale, right? That's fine. That's part of refraction. That's why I was kind of doing this when you started, because yes, optical medium, when shaped a certain way, can create magnification. There is no problem with that. Why is that contentious with what Rumpus is saying?
Well, no, they're literally saying it can act as a magnifying glass, and I've just read that it can. So basically, and they're welcome to jump on and explain it themselves. But from what I remember them saying is basically the atmosphere. You know, a lens, I guess, has sort of call it a concavity to it, right, where it's sort of curved.
Yeah.
And they're saying to have that magnification effect, like in your glasses, it's very slight, but the glass is quote unquote curved, right? Very slight, but it's curved.
No, it's not slightly curved. It's significantly curved, and it's differently curved from
right. And they would say, well, there's different layers to it, and it's curved, et cetera. And they're saying that the atmosphere can't do that. And I'm saying because there's a density gradient to the atmosphere, it can do that. And I've said that before, and
yes,
then I just read that off.
Remember when we were looking at that image of the building and showing that the lowest few floors were distorted to look smaller than the top ones?
Yes.
That's a lensing effect. That's an effect where something is diminished in size by the atmosphere.
The compression effect.
Yeah, that's also lensing. That's all of those effects are lensing effects. Right? It just depends on how the lens is shaped.
Well,
that's what refraction does.
Right, and I'm glad you're saying that, but they seem to have an issue with that concept. I don't know why, but
if you're,
I do know why.
Yeah. So if somebody's going to say, well, that explains all of the images because that is a constantly present effect for every observer, no matter where they're standing and what they're looking at, and that's kind of part of the reason why things disappear behind the horizon, then yes, I see why they're contending with that, right? Because that would mean a stable atmospheric lens against for no apparent reason. Right? No explanation. Why would a shape of? But is that shape possible? Yes, it is. Is it possible that you can see things larger than they are? Yes, and taller and lower and distorted in one or both dimensions. I see no contention there. I don't see how that helps you. And also, I don't see how it is mostly seen in the polar regions. It is most commonly seen in the polar regions. I also don't see how that helps you about looming. If it's more common in the polar regions than in Florida, that does not mean it can never happen in Florida, nor that it's always present in the polar regions.
Okay, you know what? That's fine. Let's drop that point. So the larger point then is that looming is describing what we see in the Rob Skiba video that everyone says is wrong.
Okay, so that's one that I'm not familiar with, and I don't know what that video is showing, so I can't comment on that.
Okay, do you want me to share? You want me to show you real quick?
Which one is it?
Fair enough.
Which one is it?
I'm screenshot. I was playing it earlier. It's this one here. Let me pull it back a little bit, Barney, for you, since you've not seen it. So basically, here's the setup. He's got a picture of the CN Tower that people have taken pictures of, and it's cut in half. And he has the Fresnel lens here. Who said that, Sean or Barney? I couldn't tell. Okay, so Barney hasn't seen it, so let me show him. Right. Okay, so I'm gonna play it. So it's on a flat table, and let me just fast forward just a little bit. Okay, so he pulls the camera back, and then that changes the amount of the picture you can see. The farther back he goes, the less of the bottom you can see. And the closer he gets, as he's going here, just to mimic the picture, the more of the bottom you can see. Okay? and then he mimics. See, this picture right here is actually a picture someone took, and they say, look, the bottom, call it quarter or eighth of the tower and the buildings are missing. That's the curvature. Well, he's demonstrating here that it's simply looming or lensing or magnification, and he's getting the exact same effect that they're getting in the image. and it appears cut off, but we know that it's not. And then he represents this thing here.
That's a really cool presentation. I really like that one.
But
Well,
yeah, but
Chris, hang on. But Chris, you do realize that we've touched on this before, right? Remember?
So
okay, I'm just wanting to see if you remember that we've.
A lot of people have touched on that. There's not a single baller I've come across that likes that video because it pretty much debunks the bottom part of the building missing.
That thing has been touched so much, it's useless. There's another joke, people.
It's demonstrating that very definition of looming that I just read. It's demonstrating that perfectly.
With one lens. So what situation was that?
Excuse me? Say it again?
What situation were you depicting? Because that's one lens. Remember, I just got done telling you that you keep saying the Fresnel lens like it's like that's what we see. We don't see that. So what observation?
The Fresnel lens.
No. What observation do we see that Fresnel lens was depicting?
He just showed you a comparison.
Yes.
The CN towers, the bottom eighth is cut off, and he mimicked that cut by using the Fresnel lens acting as the atmosphere.
I thought I explained it. Barney?
Yeah. So it's a really neat presentation. I actually really like it. It suffers from the problem of one observer, right? It works perfectly. It shows the horizon and things disappearing behind the horizon by being magnified and made larger, right?
Correct.
For one observer with one lens.
Correct. That's all you need. That's the person who took the real image was one observer looking through one camera lens.
Okay, so problem one. Let's just make a thought experiment. Let's say we line up ships from the coast to some distance, depending on how many ships we have. Let's say we line up 100 of them every kilometer. And they're lined up due east, and we're all looking at a sunset. Right? Are we all going to see a sunset?
I think so.
And are we all going to see the same sunset? Is the sun going to get larger and larger the closer you get to the lens? Or is it going to get misshapen or, right? He actually showed it to you in the video. When he was approaching with the camera, the effect was perfect at one perfect spot and nowhere else, right? So, and the other problem is that would have to be a common persistent effect, right? All the atmosphere always would have to be shaped like that lens and always have that exact type of looming. Because if you live on the coastline looking east, every morning you can see a sunrise. If you're looking west, every evening you can see a sunset. And it will always go into the sea. Every time be cut off in that same way, right? Do you understand what I'm trying to point out?
Not really, no.
That if it's an atmospheric effect, if it's something that's like looming, which can sometimes be present and sometimes not, right? Do you agree that looming is sometimes present and sometimes
not? Oh yeah, looming is sometimes present and sometimes not, but refraction in general is present 100% of the time.
Yes, and we understand how refraction works, right? We know we can produce optical objects based on our understanding of refraction,
right?
That have certain properties of enlarging things, making things smaller, like telescopes, microscopes, all of that. So we understand refraction.
I have a good idea, right? Chris. If Barney takes his glasses off, will you and him have the same observation?
Depends on the distance.
Something far away.
So
Barney's scratching his head. What are you getting at, Sean?
Well, I'm trying to like Rob Skiba's presentation was one person's perception, so to speak. When they do these tests, they make quote unquote variable. You would need to change the optics. They would have to depict what we see, or depict a condition that we would encounter. I mean,
well, can I tell you what Rob Skiba's test is? All it is like everything in flat Earth so far, really, is an alternative explanation. Okay, so one explanation is the building is cut off a quarter because of curve.
I don't know if you can say that.
An alternative explanation, now that we understand what the full definition of looming is, and the Rob Skiba's test is, there's now an alternative explanation for why the building is cut off.
Yes, for one observer, right? For one unique person in the universe that has a lens at exactly the right distance and right position from him, and as he moves, it moves relative to him constantly, right? That's the problem, right?
Well, no, okay, but let's not be so general. So anybody around him at that same distance, within, call it a mile to a couple miles, I would say, would see that exact same thing. They're going to see that cutoff because they're looking through. If you move a person up the beach 10 miles, say east or west, but they're looking at the same target, call it 20 or 30 miles away, however far that CN tower is, they're going to see that amount of cutoff, or very, very similar, because they're looking through the same amount of atmosphere, 20 or 30 miles across.
Yes, but a person who is on a ship, which is at that distance where that man's lens or magnifying Fresnel is, it doesn't have to be a Fresnel, it can be any kind of lens, but who is at that distance would see a massive distortion, as though you take a magnifying glass and just put it in front of your face, right? So it does work for one observer, which is why I really like it. It like, if you set up the universe specially for one observer, for yourself or for the camera, you can have an alternative explanation which works, and I really like that. I like those explanations. But it doesn't work for every observer. It works for one special observer.
But why do you say that? I don't understand why you're saying that. Who would not see the same thing at a relatively same distance away from that same object?
Okay, I'll try, but I don't think I can draw quite that fast.
I mean, so are you saying that someone else should see more or less of the building depending on where they are at an equal distance? Or I don't get what you're saying. Like, if I'm 10 miles east but still 20 miles from the target, should I see more or less of it based on what you just said?
Share.
I'm only going to have a few more minutes, by the way, just FYI. But.
So let's say I have a lens of some kind, right? And there is an object that I'm viewing here, and I'm the observer here, right? And I'm looking through that lens, and I'm getting a kind of go the fuck away. No, that's not what I wanted to do. I'm sorry, I'll try to be quick about it.
No problem.
Okay, so the distortion of the lens for the viewer here is perfect to make things focus in a certain position in a certain place, right?
Yes.
But if there is another observer, which is here, or here, or here, that lens does not work for them. The distortion of the lens for the viewer...
But if you're that close, you wouldn't need to, because then you would see the whole thing, and you would say, oh, look, it's because I'm closer, and there's no curve closer,
in a certain place.
But we know now, at least, as an alternative explanation, that the further you are, the more density gradient you're looking through the atmosphere,
or
you can cause that, call it looming or magnification of the distant object.
Of the lens for the
but if you're that close, you wouldn't need to, because then you would see the whole thing and you would say, oh, look, it's because I'm closer and there's no curve. You still there? Hello? Is Barney still there? Did he drop? It looks like his system may have froze. Oh,
I'm back. Sorry. How long was I gone?
About 30 seconds.
Right? Do you get that this lens, this Fresnel lens, does that for this observer? Damn it! I need to reshare my screen if I'm going to be pointing at things. That this lens works for this observer in observing this object, but it doesn't work for this observer or this observer or this observer or this observer in the same way, right?
Yeah, but did you hear my explanation for why?
Possibly not.
Okay, well, it's obviously because you're closer to the object, so it doesn't. Of course, it's going to change. But see, the baller would say, "Oh, look, I'm closer and I can see the whole thing because there's less curvature." Well, I'm saying I can see the whole thing because there's less refraction.
Okay, and the problem that I see with that is that we can all see a sunset every day, right? From every position that sees the horizon due west, and sunrise every day and every horizon when we look due east. And that would imply that this person here also has a Fresnel lens here and doesn't see this one, right?
No, I'm not following.
And that's an effect that's always present for every observer, always. Right? You never see the sun disappearing.
By the way, you never see the sun disappear. Sorry, what? You cut out.
You never see the sun disappear off into the distance. You always see it set. Whenever there is a sunset.
I've seen one video of it disappear off into the distance.
I would love to see that. I would be really amazed to see that.
I can pull it up. Look, I mean, Barney, you seem honest, so, but, ballers just seen it just make excuses. Hold on a second. Let me see if I can find it. YouTube, the way YouTube works. Oh, here it is. Here, let me pull the video up. No, I didn't say that, Sean. I'm just simply giving you alternatives. No, listen, Barney said he's never seen the sun disappear. And I'm saying there's one video that I've seen of a guy, David Weiss. Here, I'll fast forward it. So by the way, he's using a drone, okay, which means it's higher up. Okay, well, see, that's what I'm saying is by excuse, you're going to say use the wrong filter. Let's just let Barney watch the video. Okay, so he's got a drone, and there, you see the sunset. Now, and the ball says that the Earth's spinning away, and it should just set, right? We shouldn't see it disappear, but here we see it disappear into, call it the haze or the atmosphere or whatever.
We see what? We see a very unfocused image and the light bleeding out from...
Well, okay, so he's showing something on here. Let me get it to the point. Let's watch it.
Yeah, Chris, man.
Yeah, so if you unfocus your image...
Hold on,
if you unfocus your image and the bright object bleeds through your filter, it will appear larger, right?
I'm not worried about that. Look, the sun just disappeared.
Yes, that's called looking at an unfocused image. Are you one of those flat earthers that claim that when they turn off the focus on their telescope that they're looking at the real shape of Jupiter?
No.
right?
Definitely.
And this is the effect that we're watching, right? An unfocused image.
But why would he be changing the focus? The sun is just going, it's just disappearing. Why would the focus make it?
You seriously do not see that that's an unfocused image?
It's because he has
But it's
a
unfocused the whole
narrative.
way.
Hey, Chris, he has a narrative he has to run. That's a good answer. I think
But then
that's
it's
why he does
unfocused
it.
the whole way. Unfocusing wouldn't make it go out of view. It would just make it blurry, and it's going
Oh
out
my
of
God.
view where you can't see it anymore.
You want? I got pictures of stars out of focus. You want to see what that looks like?
Yeah, Sean, and you can still see them. Is my point.
No, you can't. You could not tell these things are stars
Okay,
when
but
that
listen,
happens.
I don't even want to spend time on this video. But Barney, just
No,
FYI,
fair enough. Okay. FYI, I'm now informed.
That's it. Thank you. Barney gets it.
Thank you. I appreciate it.
Okay.
Thank you,
Whether
Chris.
you agree with it, disagree with it, I'm just
definitely
giving you the info.
Cool. I don't know.
But Sean, listen though, you have to be mindful that not everyone has seen and heard everything you've seen and heard.
No,
You're right,
absolutely.
100% true.
The curse of knowledge is a problem, right? When you know something, you kind of instinctively assume that everybody knows that piece of information in the exact form that you know it, and that the form that you know is the only correct form, and that happens on both sides constantly. That's one of the more annoying things when watching.
Yeah, I agree.
I
agree. And just to be fair, I've seen those videos of the blurry like shape shifting stars, and I've seen people demonstrate that here using like lamps, like a lamp light doing the same effect. So obviously, I know that most likely it's just an out of focus light.
Yes. Right. So the actual shape of the sun in that video, I'm assuming, I'm kind of surmising based on my experience and knowledge with not focusing things, is that yes, the disk of the sun is setting behind the horizon, and as it gets diminished, the circle that you see unfocused, the spot, the unfocused light blur, there is a technical term that I can't bring up right now, right? Is just looking at, as you see less and less of the sun, it just looks like it's diminishing in intensity. But you've seen images of stars done that way, and you've seen images of plants done that way, and images of lights on the street done that way. You know what the effect is.
I have to go on mute for a second. Sorry. Carry on.
There's your star.
Amoebas in the sky.
Hey, oh shit! Hey, Pete, there's a fucking dodo in it. God damn it, Pete! Pete got me. Fucking got me. Pete fucking got me. There's a dodo in the picture. Damn it! Pete got me.
It looks more like a vulture.
Come on, man. Can't be so literal. Didn't you listen to Pete? Hey, man, I'm sorry. It may be flat. Pete's shit's making sense, man.
Ever since I realized that Obama and Will Smith are the same person, it all makes sense. Aristarchus.
Poor Carlos, he wants to scream that out. I think it's it's a good idea. You know what we should do? We should talk about some terms and stuff like that.
We should talk about Sleeping Warrior.
Yes, that's really what this is all about. Because I am 100% caveman to the knowledge of Barney. So Anthony has
and my knowledge is definitely not on a professional level. I'm an amateur as much as anybody in these discussions.
Yeah, but that's a big gap in between there. And if for the information he can get. So if you're learning from me, Riley, shame on you. Shame on you.
When you build me up like that, it creates the problem of people like Kibo coming in and saying, Barney, he's your guy for proving everything.
I like to say it right now. I'm going to say this right now. Barney is my guy for proving everything. He's smarter than me, so I do look to him for advice. That's what it is, advice. I put it this way, we were talking about gravity and the force and this and that. He put me onto a documentary. I've now 3 documentaries in of something else or the same topic, but all Party does is fill in some blanks and helps my journey. And then I keep going. I'm still looking. I don't. He's not my
It's not a
source.
documentary.
No,
It's
no,
not a
no. Yeah,
documentary.
yeah,
It's the messenger lectures from Richard Feynman,
yeah. Yeah, yeah.
and
I'm sorry.
they're
Yeah.
brilliant. For the first one is explaining science literally through how we know that gravity works and how we've come about it and how we've discovered it. And like 99% of the questions that get asked about gravity in these hangouts is in that single lecture,
I noticed
just laid out perfectly, beautifully. Ah,
that. And more importantly, it 100% explains why it's a force. Like he lays it out, and he lays it out so well.
yes.
It's a that's why I'm so confident in telling people it's a fucking force to me, because I got that. I know I get that. Once it goes past that, just like put it this way, I'm living before Einstein, because everything Einstein did when it comes to space to time curvature, I haven't got there yet. It means zero to me. My life does
I
not
know,
change, but I need to learn it. But that's why it's a force to me, people.
a lot of people in flat Earth debate communities aren't actually challenging Einstein, nor are they even challenging Newton nor Galileo. They're actually going all the way back and challenging Pythagoras and what's the Eureka guy? Damn it, escapes me right now.
Hey, I'm back, by the way. FYI.
Just kidding.
Welcome back. Okay, let's get on it. Let's get on the topic that's
Yes.
been trying to be covered for 3. Okay, go
Yeah,
ahead.
for real. So and Chris, this is actually perfect that you're here, because I think you suffer from this. The terms, these things really matter, because as Barney was saying, and I've been dealing with, is Riley. Is it does he not understand it, or does he has to purposely do it? And just so everyone
No,
knows, I've invited him here dozens of times now. I've even been in Nathan's chats.
so I can actually model Riley as an honest interlocutor who has an understanding of his own and is just reading things through his understanding, being only critical with things that disagree with him, and not reading it, not trying to understand what it's saying, but checking whether it's agreeing with him and finding that it does, and constantly finding that it does, and just literally skipping through the next few sentences or the sentences before it, or like it for me it looks very much like a case of accidental cherry picking, like confirmation bias.
Yeah, but is that confirmation bias when you start denouncing gravity altogether?
So
Because here's a problem I have, and like again, maybe I'm here. I'm not. Maybe we're saying the same thing, and I'm not saying it right. Maybe, but like everything they use to disprove gravity needs gravity. Like Chris, understand something. I think I've heard you say it's density before. If you didn't, I apologize. But it can't be density, because density needs gravity to be density. Buoyancy. Wait.
no, it
Okay,
doesn't.
it's mass. I'm sorry, mass. Wait, hang on, because I said this earlier. So this rant has been
Mass
said
theory is
before.
weight.
Huh? Say again.
Yeah, it's not density or
No,
mass. It is
no.
weight.
I got ahead of myself. Buoyancy and hang on one second.
Buoyancy requires gravity, yes.
Yes, and it can't.
And
It's nothing without it. And same with weight. Like,
And a density gradient also requires gravity.
yes, that too, because gravity is the container.
Yes, in a sense, yes.
Yeah, I mean that's it. Now, you were saying earlier, is that if you're looking for alternative ways to explain things, more power to you. But for instance, let's try. Can you try to show me an alternative that doesn't require gravity to exist, or you know what I mean?
Well, again, it depends on how you're defining these things. You're saying the
Right.
word gravity. What the word gravity really is
The force.
an acceleration of 9.8 meters per second. Okay, so no one's
Well,
denying
on the surface of the Earth, yes.
The
okay,
number,
fine.
the 9.8.
In general, the sort of layman's definition, right? Not you're saying gravity. I'm saying 9.8 meters per second squared
On Earth.
acceleration. There's no one
It's the
denying.
force.
Okay, fine. There's no one denying that concept or reality. Even it's just what is the cause of that. So one thing I don't get
Wait.
why can buoyancy be a force, but density can't be a force?
Correct me if I'm wrong, but no one knows what the force is. No one knows what the
I said,
cause of
why is
gravity.
buoyancy a force and density is not a force?
There's no vector.
So because there is a technical definition of what a force is.
I can read it.
Right. So then
Right?
why can't buoyancy be the cause of things going up and down?
Because buoyancy.
No, it's so the cause of things moving is inertia. The cause of things changing their motion is a force, right? You can have forces of different kinds in different frames of reference, of all kinds, and all of those, everything that changes a motion, an inertial motion of an object in any given frame of reference is a force. So buoyancy is a force. If you take a balloon and put it underwater and let it go, it won't just stay fixed. It will pick up a direction and start accelerating that way until it reaches terminal velocity and then keep moving that way. That's a force, something that makes something else move. Now, with buoyancy, we have a mechanism of how that works, which involves density, but it doesn't make density a force, nor does it make relative density a force.
So buoyancy is a force because it pushes things up, right?
Yes.
So why is it not also the same force that pushes things down? Why can't I just say if something's more
it doesn't
buoyant,
push anything down?
Why can't I just say if something's more buoyant, it goes up, but if it's less buoyant, it goes down? Or maybe I said this backwards, but either you see what I'm saying though, right?
So this is going to sound just polemical, but you can say whatever you want, right? That does not help if the concept doesn't work. So if you're just going to say it, then I'm going to say whatever. I don't care unless you show me how that works. How does that thing impart force and create motion upwards and downwards for these things and those things? How can I compare it to reality? How can I verify that? What are the quantities and classes and variables and concepts that you've used in your statement? Because that statement, as just stated, it doesn't mean anything to me. Right? I don't know what it means. I don't know what it means that density causes things to go up.
Well, buoyancy causes things to go up. And I'm just thinking, by the way, I mean, yeah, I hear what you're saying. So just play along if you don't mind. So buoyancy causes things to go up. Like, for example, the helium balloon. Well, it's really the buoyant force pushing on the balloon to go up, right?
Okay.
So why is it not equally either the buoyant force pushing things down that are more buoyant, or density pushing things down that are more dense, right? So why is buoyancy only one direction?
So do you want me to explain the concept of buoyancy to you? Is that what you're asking? How does it work? So it was.
But specifically address why buoyancy is only one direction.
Yes. It's not. It's not. It's definitely not. So I am not going up, but there is a buoyant force acting upwards on me. I weigh, when you put me on a scale, my weight as measured by the scale is exactly diminished by the amount of air that I have displaced, which is trying to take up that place, right? In an atmosphere. And if I'm in water, my weight will be decreased exactly by the same volume of water that my body occupies. Do you get that?
Yeah.
So buoyancy always acts upon you as long as you're surrounded, as long as you're in a medium with mass. The mass that you have displaced, that is trying to get back into the place where it was, is what is the exact force of buoyancy acting upon you. Whether it's succeeding in lifting you or not depends on whether you're more or less dense than the medium that you have displaced.
Right, and what you've defined so far is the flat Earth definition of why things go up and down. If I have a helium balloon in a vacuum, and I have air in it so far, but I haven't evacuated the air, and the helium balloon is at the top due to the buoyant force of the air below it pushing up. If I remove the air, the buoyant force is either reduced or gone and causes the balloon to go down. If I add air, it causes it to go up. If I remove the air again, it causes it to go down. Why is that not good enough?
That is not good enough because there must be a preferential direction of motion. There must be some force pushing all things down to create buoyancy, right?
See
that water that is trying to get into your place. The reason why it lifts you up, if you're less dense than water, if your mass is less than the volume you displace, is because that water is also trying to fall down due to gravity, and that's what's pushing you out of the way. It's literally the two-pronged scales, right? When you put the weight on the one side and the object you're weighing on the other, right? It would be exactly the same as you standing on one side of the scale, and on the other you put your exact volume of water. Yeah, and if the water can push you down, then you will be pushed up. And if it can't, then you will push down and the water will be pushed up.
Chris, you know the beach balloons, the beach balls that you can fill up with air? It's like if you had two and one was completely took all the air out and it was scrunched up and it was just there's no air in it. Its buoyant force is going to be different than the one with that's blown up. If you it's 10 feet deep, see what I'm saying? Like it's going to change because of gravity. Like gravity, I don't know how to explain it. It's to pop up like it does. It has to be going against something to give it that oomph. Doesn't make any sense at all.
I mean, not really. So here's my problem with gravity.
Thanks, Chris.
Sorry, I'm just being honest.
I know. No worries.
My biggest problem with gravity is, and I said null the other day, and maybe I meant alternative. I have to look at the definitions more closely. But there's either no null or alternative hypothesis to gravity. In other words, you have to remove yourself from that system that you're trying to prove or disprove. So in other words, if we're always under the pressure of or the force of gravity, how can we disprove gravity if we're always under the influence? There's absolutely no way.
This is why we can't make a fucking globe with a fucking ocean on it to show you guys. Thank you, Chris, for answering that.
So then, in my opinion, at best, we're at a stalemate again.
No.
The question that you've asked has been asked by scientists, right? There were scientists and philosophers who were deeply troubled by that question. And then this really smart guy came up with the experiment of how to test that by saying, yes, all things point down towards the Earth, but can I measure that Newton's formula that describes how things are attracted to each other in a way which completely disregards the gravity of the Earth, which just doesn't measure that, but measures some other attractive force in another direction by other. And that guy was Cavendish, and he came up with the Cavendish experiment, right? And that's how he before Cavendish did his experiment, there was no way, like all you could say is that it's proportional to r squared, and it's inversely proportional to the distance squared, and it's proportional to the masses, both of them together, but you don't really know how. There is, you know that there is some constant there that you need to multiply it, or some value which might have meaning or might not, but you don't know what that value is, and you cannot establish the exact force, right? And Cavendish found a way to measure by varying the masses how those things relate to each other, and from that derive G, from G derive the mass of the Earth. He actually didn't consider it relevant to say what G was. He didn't write it down. He just tried to get to the mass of the Earth from gravity. But his same experiment was used later to get the exact number, which can be reproduced and used over and over and over again. That is the exact answer to your question. There are things that you cannot completely remove, or that you cannot manipulate in a way that Riley wants, where you can just pull a lever and have the Earth rotate at a different rate, or right, have it turn this way and then have it turn that way. We simply do not have the technology to do that. We do not have the ability to do that. Right. But we can approximate them by analogy, by creating those same conditions in a different way in which we can control them, and then comparing the results of that to what we're trying to measure, the thing that we cannot change.
Fair enough. Hey, I appreciate your all's time. I do have to go. Got to go to the store and get some supplies. I'm doing my first grill for the summer. So.
Oh, I know how that is.
Thanks for the chat, Barney and Sean. I'll see you guys later.
Yeah, have a good one,
Chris. Yeah, and thanks for the pleasant conversation.
Now, we get back to this list. So
yes.
We're going to kind of burn through them because I want to get the panel open, but good thing I got some highlighted too. So, but let's go over proof, because this one is awesome. And I think we did some of these. I kind of went over a couple of these yesterday, or remember, but we're going to do it again because you lads are still saying shit wrong, so they didn't listen. Proof. Here's a kicker. I now know science doesn't prove shit.
Yep.
Nothing, they don't want to prove. That's not what they do. It's like the ice cream guy. I'm sorry. He just doesn't want to make burritos. This is how it is. Sorry, guys. And it says right here, the science use for the term proof, because it is a term in science. This is why you guys think like you do. But listen now you understand. Scientific use. In science, there are no proofs. Only indications or evidence for support that disproves a hypothesis. There are only proofs in philosophy. In mathematics and logic, the validity of a claim must be determined according to the certain set of laws and rules of inference. A proof must demonstrate the proven claim is always right, without exception. Then, the regular use. Actually, I think I should probably do those first. But the reason you guys are thinking the way you are is because the everyday use infers that it's complete, truthful, or something indisputable in testimony. It's just so you can find. Do you understand the difference between what was just read? I hope so. I mean, I really do. Theory.
So,
go ahead.
In respect to Riley, he has these two words that he insists are part of science. One is that it shows causes, which is sometimes true and sometimes not. And when it's true, then his independent variable statement holds, but he's misusing it. And the other one is that science absolutely does prove things. And his own, like those same documents that he is constantly showing for what the definition of independent variable is, disagree with him on that. Or at the very least, explain something completely different. Nowhere talking about proof, nowhere talking about causation, nowhere, right?
That's fun.
Okay. Sorry, I interrupted you.
No, you're good. Good old theory. This one, I think this one is probably the easiest one for a flat earther that they attack. Because gravity, remember, gravity is just a theory. When we look at it, and I know this time I'm gonna use like the everyday term, the term that we all thought we knew it. Theory, or the term theory is. People often say theory, and actually means hypothesis. Feeling, a hunch, an idea that has been verified. I have a theory that my sock disappeared from the washing machine because an elf stole it. We got to make that a law, but yeah. That's common knowledge theory. I mean, that's what everyone assumes a theory means. But when we're talking science, theory is different. Theory means a lot more. Like, theory is like some important shit now. Like, you can discredit anybody's shit with a theory. Like, oh, that's a theory, dude. I don't care. But when we're talking science, you need to understand that theory has power. The scientific term of it is a theory is a well-founded and comprehensive explanation of a certain phenomenon in the world. The explanation is backed by generous amounts of evidence, and the hypothesis was reinforced by studies and observations done repeatedly over time. Theories are... But
I very much disagree with that definition given there. It is very popularly ascribed to science, and it doesn't hold up.
What do you mean?
So a theory is a complex of different confirmed or unconfirmed hypotheses that makes a meaningful whole, right? Because even today, we are talking about people holding to the miasma theory of disease, right? Which was then in competition and defeating the germ theory.
Okay, yeah,
we talk about atomic theory. We talk about Lesage's theory of gravitation, right? We talk about those theories were never, like Lesage's theory of gravitation never came up to that standard that is proposed in that definition. So it's not merely that you have a hypothesis and when that hypothesis comes up, you have a theory. No, you have a theory when you have a complete explanation, when you have a model, when you have enough information in your hypothetical explanations that you can describe the entire process. Then you have a theory. That theory can be right, it can be wrong, it can be supported by evidence, it can be experimentally disproven, right? But it's still a theory.
Because I only read the second half. I see that, but I kind of see what you're saying. But then I'm also confused. What is? Yeah, so they're not describing a theory. A theory's been done. Like everything's been done for the theory. Where in this description, it seems kind of like they're saying the process.
they're kind of what they're describing there. I would call a standing theory, right? The theory that actually stands, that's valid, that has been experimentally proven.
But there are theories that okay.
But there are theories which have been disproven, and they're still theories.
But isn't that we move down? Isn't that what a law is, though? Isn't a law that doesn't a theory become a law, or is it
No.
No.
A theory and the law are two different things, right?
Okay.
Completely. And we've talked about laws previously.
Yes.
So Newton's laws of gravitation were laws. They were not a theory. They were not an explanation or in Newtonian gravity, there was no explanation of what causes it or how it causes it or how it comes about, or it was just a mathematical description accurately of what happens that coincides with the movements of heavenly bodies that as observed from Earth, with things falling down here on Earth, and still holds up in orbital mechanics. And it's a description. It's these mathematical relations hold, right? We don't care why. We use in the world of Newton. We don't know what gravity is. We don't care what gravity is. We don't know what causes gravity. Gravity is just a word in the English language that we use to describe things falling down.
Okay.
Right? When I talk about things being heavy, things falling down, things standing on the surface and not floating away, I'm the overall word I'm going to use for all the phenomena that are related to that same thing, I'm going to call it gravity. And I'm not going to bother with what it is, it's gravity, right? And it's really funny to hear a lot of flat earthers kind of say there is no gravity. Yes, there is. That kind of gravity here, it's demonstrated. It's there. I'm not floating out of my chair. There is gravity. That's what Newton's gravity is. Newton's laws are, I've told you, you take measurements, you make observations, you take the paths of, you've seen the Feynman lecture, right? You take the paths of the Keplerian paths of the planets, and all of those things have in them a single relationship, which is that the force acting on an object is proportional to the masses of two objects in their interaction and inversely proportional to the square of their distance. That's all. When you read Principia, it doesn't have the F equals G mm over R squared. It literally has, it's proportional to the masses and inversely proportional to the distance squared. All there is to it. We don't know what G is. We don't know what other factors come into play. But when we fiddle with mass, we get a different effect. When we fiddle with distance, we get a different effect. Right?
Okay.
And that is a law. That actually is the law. Also, in this explanation on screen, it says laws can never be disproven. They cannot be disproven, but they can be confined. And that's what happened to Newton's law. Right?
So it says, if a law were to ever be shown false, then any science built on that law would also be wrong. Then the domino effect would have a new and devastating meaning. Laws generally rely on consistent. Okay, so this is where the equations come in. Test it with an observation with these equations that will work, right? This is kind of stating like all these things will always work the same.
Again, I might be wrong. I disagree with your source. I think it looks like it's from an elementary school book or something like that. It's something that somebody has written up to get the concepts over in as few sentences as possible.
Uh-huh.
But
this,
I don't.
This came out of, I guess it was like, it's like a publication. I know that it was peer reviewed, but it's just it's the parts of it that I could get to, and then this is the main part, the list right here. These are just terms that were in the same article on the same publication on it. But everything I got it from was with a very distinct need to know terms of science, or the transition from general to the scientific terms. That's where I tore through all those things.
Yeah, no, I really disagree with a lot of these.
Well, like, what do you disagree with here? Because that's pretty damn important. If you don't agree with it, and you obviously have a better understanding than I do, then what part?
So again, entropy, right?
Okay.
It uses that pop sci definition of it. It relates to its internal state of disorder. Yes, you can use that to illustrate entropy, but that's not what entropy is. Because if you have a gas, and let's say you have a carbon gas, and you coalesce it into a diamond by atomic deposition, you are creating an ordered structure, and that process is increasing entropy. Right? Because the energy being released will make something else move chaotically. And you can get the best description of entropy that I've seen so far, kind of that illustrative popular description is: take a cup, take a barista cafe latte, which has appropriately layered coffee and milk, right? And then put a spoon in and gently stir it. First, you have a very ordered state where those two layers are fully distinct. Then, while you're stirring, while you're inputting energy into the system, while you're adding motion, you will get vortices, and you will get these complex shapes that have a lot of structure within them, and that have a lot of meaning in them, right? A vortex of two, like, you will get spirals and shapes and like complex states until they even out and you get chaos.
Yeah, okay.
But entropy can produce, in going through, entropy can produce order and can produce elaborate and complex order.
Which is way over my head at the moment. So let's continue. Just so you know, Barney, I'm gonna open the panel up, but here's the kicker to this one. I'm tired, but I'm not tired enough that I don't want to be doing this. I just don't want to get all amped up. I got amped up earlier. So I'm all amped out. So like, if anybody comes on this panel and they get all like, start getting everything all worked up again, I'm gonna end the stream, because I'm not in the mood to get all amped up. I like to have nice chill discussion. I was gonna do the links individually, so just know, if you guys come on, it is a chill panel today. Today we're not proving shit. Like, today is not the day we're gonna tell flat earthers what they need to know because it's flat. I just want to have a conversation with my boy Barney and whoever else comes on here about how obviously some of the shit I find is still wrong. But guess what? Now I know.
Yeah, things are correct in degrees, and things are useful in degrees. That's the kind of more important and salient point. This kind of explanation is very useful to a person in elementary school, a student trying to grasp a whole slew of new concepts all at once.
That's what this
and
is.
you
Yeah, that's what this is.
And and you just tell them that bit which is relevant for the lessons that they're going to learn right now. And there are problems with that, but that is the way we teach things. Why? Because understanding everything and like getting into the nitty-gritty, when you have a fixed amount of hours to get somebody to pass an exam on these things, you're never going to do it, right?
Okay,
and
so
so you give them the initial understanding, and they will clear up where the misunderstanding is. But underneath all of these definitions, and there is a meaning, and that meaning is relevant. You need to get to that meaning. You need to understand what it is to be able to work with it.
So what you're saying is the art. So far, what I presented so far is, so to speak, a Neil deGrasse Tyson version of what's going on.
Excuse me.
Manny, what's up, Pete? How you doing, George? What's up,
Hey,
farmers?
guys.
Blue's in the house. What's up,
Oh,
Blue?
Hey.
Uh,
We good again, Sean?
Can I have a question
You friends
for-
again, bud?
we're always good, Pete. I just want to make sure today we just keep it all calm, because I'm in a good, calm,
All right.
good mood. I got
you
the
used to chew.
vape pen.
We're just asking questions here, and Barney is very knowledgeable. No one will deny him that.
So you can find my brother.
absolutely.
How
I
you
guess
doing, my friend?
helping them think better, I guess.
One thing to make clear once again, and I've said it before, I have a clear understanding of these things. That does not mean that understanding is correct.
Yeah,
I am very knowledgeable about the things that I know. Like everybody else, I don't know whether I'm right or wrong, and I don't know what are the things that I don't know. So yes, you are supposed, like, if you're just drinking in the wisdom that Barney speaks, fuck off. No. Just forget everything I said. Go read. Go research. Try to understand it.
Like I said, Barney is my source for all knowledge and wisdom. I have a little book that I have right here in front of me. It's called The Barney.
Barney's manual.
Oh, Barney. And every day, 5 times a day, at 1:26, 37 seconds, I do that.
Masturbate to Barney's manual.
No, wait, damn, Pete. Why is it always got to get like that?
That's a joke. Come on, we can do wanking jokes.
There is a proverb that goes something like, join or follow the person who is seeking for truth, but fear the person who has found it. I'm not saying that I possess the truth. I possess an understanding that I'm willing to share.
Well, Barney, let me ask you, sorry, Sean, let me just ask Barney one quick question, and I'll leave him ponder on it, and I'll shut up then. My question to you, Barney, is just in general, I ask people that, why cannot the Earth be flat and stationary? And you don't have to answer. Please answer that later on. I'm just thinking. I know. I'm just saying, why can it not be?
Because God doesn't like flat and stationary. He likes spheres.
Okay.
Can I answer that for Pete? I mean, not that he hasn't heard this.
Nonsense, say hi to me, George.
Before. Say what?
In principle, there is no reason.
It takes a bit of thinking, reconsideration.
I can't hear you, Q.
Yeah.
In principle, there is no reason why it couldn't
Barney,
be.
hear me.
Except
Barney, people are trying to speak periodically, Barney.
Hang on, Barney. Barney, can you hear Q?
Hi, guys.
I can hear Q. Hi, Q.
Hi, Q.
Hello, everyone.
Hello. Barney, you were talking over Q quite a bit. She was asking me a question. I could not hear her.
I'm sorry. I thought Pete asked me a question that I needed to answer.
I've actually already established it. There is a lag between. I've said certain things, and I can tell, and I actually look at Barney when I say things sometimes, and his reaction shows me there's a lag.
Well, then he should.
Barney.
And Barney
from the third of the world away.
Join the Barney religion,
Barney
people.
should just maybe chill a little bit and pause a bit to see if someone is speaking.
Well, no. Well, everyone just got here, so he has been on an empty panel, so it's not really his fault. It's not his fault.
It's coats off time, introduction time,
Pete,
a little hustle bustle, and now off you go, Sean.
But Pete, I love you, man. But today,
just talking, man. Come on.
I know. Just I'm down for him. But
off George, let George go on then to say what he has to say.
Yeah, anybody can talk, but we're doing calm today, guys. I'm all zen the fuck
out.
out.
Take it easy, Sean. I'm all up for calm conversation. Off you go.
I like. Where's that term from? Off you go.
Off you go as in, well, you're sort of taking, turns to talk. So off you go. You talk away.
Away with you.
Yeah, away with you. Off you go.
Okay. Did anyone want to touch on what we've kind of been going over so far?
Sure, the scientific method.
Yep.
I certainly did as well. Yeah.
Yeah. Talk about everything. That's what we're here for.
So it just seems like you guys are saying the wrong idea about the scientific method.
We're doing more terms than describing the method right now.
Okay.
As far as I know, I would say the scientific method is just, that's my bag of tools, right? That I put to the side. Right now, we're trying to figure out what profession we're doing. We got to know what we're doing first. We got to know what everything means first.
Might I make a suggestion, Sean?
Absolutely.
Is if people are going to get into the scientific method, I mean, it's been so bastardized by Quantum Eraser and
what's the language there,
George? No, shut up, Pete.
No, George. I got Pete.
Video.
I got Pete. Pete,
wait, there's a very good video. It's about 16 minutes long, produced by Gem Panda 2020 or 12, whatever you call it. Gem Panda, anyway. It was put up about 2 weeks ago, and it's very excellently done. I recommend anybody watch it if they want to learn more about the scientific method as related to how Nathan and Quantum Eraser has so distorted and bastardized the whole concept.
How did they distort it and bastardize it?
Go watch the video.
Okay, watch the video. Don't have a discussion about anything. Watch the video. There's no greater term bastardized than gravity, right, George?
And then Howard, we can discuss it. Watch the video first. Jim did a very excellent job, and it's only about 15, 16 minutes long.
Okay, what's your understanding of the scientific method?
Talk your way through it, George. Answer Howard's question directly.
16 or 60.
All right, let's get off the connotation.
You do not have to invoke the scientific method on everything you do to ascertain information in science. Not everything has to strictly hold to a scientific method.
Yep.
You can make measurements, you can make observations, and you can ascertain causes and effects without having to go through a strict discipline of the scientific method.
They agree with that, though, George, and I agree with that. And I actually said that to Quantum Eraser and Nathan, and they agree with that.
I would think it would be.
I don't think so.
I think when the scientific method is brought up, I think it's used too literal, as in, like I said, it's like it wouldn't be a set structured thing, because if it was,
it has to be though, Sean.
No. Again, all it is a way for all the other scientists or whatever they're that any science that being tested or whatever. It's just their way of being able to go, hey, fucker, I know there's a way for me to fact check you. Just remember that. Oh, and to make sure you don't think I'm lying, I'm gonna have this route, and you'll have the tools to be able to fact check me. That's all the scientific method is.
But what goes on over in Nathan's channel with Nathan and Riley and Quantum Eraser, they're using it as a tool to shut people down. Yes. That's all they do is they're using this whole thing. Well, what's your independent variable? What's your dependent variable? And then by the time you get through with this nonsense of discussing this, you're off your game and you forgot what the heck you're talking about in the first
George,
place.
give us an example then. Give us an example. Can I just say before you do give us an example where you can use the scientific method, but not in such a stringent sense to ascertain cause and effect. Can I just say that my realization regarding Aristarchus does not fall within the scientific method, and I'm glad to hear that you agree that everything doesn't have to fall within it for cause and effect.
Well, case in point, if you want to know a case in point, if you look at what they consider, let's say Quantum Eraser considers as the pure science, he talks about quantum mechanics. All right. Well, tell me how, using the scientific method, you determine the Heisenberg uncertainty principle and the value that it has, which is Planck's constant divided by 4 pi. That's quantum mechanics is a highly mathematical theory.
Yeah.
And
I absolutely agree,
the Heisenberg uncertainty principle, you have to invoke the mathematics. There is no testing of hypothesis through scientific method to get that value of Planck's constant divided by 4 pi for the value of the Heisenberg uncertainty.
Right, George, but he's not here now, and I actually agree with you, and I pulled him up on these things. Show me a photon. I mean, we have to accept certain things when it comes to his philosophizing, but I'm asking you regarding the scientific method in
do you got
something that
eyes
you
that
would
can
use.
even see photons? Do you even have eyes that can see photons, Pete? How can you ask us to show us a photon if you don't even have eyes that can see it?
Okay, Q, you can get a tweezers apparently and isolate one of these massless particles and split it in two.
Tweezers?
Well, you had the microscopic
what kind of tweezers you got, Pete?
Well, exactly. That's what quantum eraser is telling you they can do. But anyway, my question was to George: how has, in terms of your science, George, how has the scientific method been applied and proven cause and effect without sticking stringently to quantum eraser's description of the method itself? Can you just give me an example of that? That's what I'm asking.
All the scientific method has been used?
Right, in not so stringent a sense, and has proven cause and effect relationship in the science that you accept. That's what I'm saying. Do you understand that? Do you understand that question, anyone?
Well, here's the thing I was going to say.
I understand your question.
But here's the problem. I don't. And here's what I was going to say. How come you guys can't just ask simple shit? Because it's like really simple shit that I understand. And I know it's a fucking globe. So like if you talk simple shit, much easier than talking shit you just know word salad wise. It's like you just said
what's
something.
What's the shape of a photon?
Like you just said a whole paragraph of shit, and it meant nothing to anything. Like you didn't say anything.
That my question was good, man. Ask Barney, was my question good?
No, go ahead, George. I'm sorry.
I have no idea what you asked.
Yeah, I'm sorry. I
but you don't know. Probably quantum eraser, Barney.
Say that.
How about a very simple...
George was making a reference to quantum eraser, and George said he understood my question. I'm just looking for an example of an experiment.
Yeah. How about a very simple experiment? Let's consider the freezing point of water.
Okay.
Now, what kind of variables might impact that? We could have atmospheric pressure. We could have temperature. Those are the two obvious things. So let's say we have water in a container. And in that container, we have a closed container, and we put a certain pressure in that container. Let's start out with atmospheric pressure. And we close the container, and then we lower the temperature, and we notice when the water changes phase from liquid to solid to ice. So we note the temperature. Okay. Now let's change the pressure. Let's up it to, say, 1.5 atmospheres. We do the same thing. We lower the temperature. We see at what temperature the ice freezes. Okay, we can do this sort of thing. And by isolating variables one at a time, we can basically plot a diagram of freezing point of water versus pressure.
Right, isolating variables. So in any particular experiment, you will have one variable, right? You'll have one independent variable, one dependent variable, and you'll take it from there. So we understand that the experiment you just gave there, when you decrease, or you think you keep the pressure constant, but when you decrease the temperature, the pressure will also decrease, right, George? So there is this relationship.
No, you can control that. You can have a pressure gauge, and you can adjust the pressure so it remains constant as you drop the temperature.
Well, then you have a different input, then, don't you? You have two inputs. So you have the
you don't have
pressure input.
You're holding the temperature, or you're holding the pressure constant by, as the air temperature is decreasing, the pressure is going to decrease. So you put a little more air in there to bring the pressure back up, so it's at the same value, and you hold that value constant by adjusting the pressure within the container, so that as you're dropping the temperature, the pressure remains constant. Very easy.
So that wouldn't be the independent variable then, would it?
The independent variable would be the temperature.
Right. So the pressure comes outside
But you could do the same sort of thing. Now,
again, we have one variable, George.
Now you can do it in another way. You could adjust the pressure by holding the temperature constant.
Exactly.
So now you use the pressure as the independent variable, and you hold the temperature constant.
And that's fair enough. What would Quantum Eraser object to, since this is what it's about? What would he object to in what you said there?
The way they look at it, it says, "Oh no, you have two variables there."
They'll say that you have
two experiments, George.
What they don't understand is you can have many parameters or many variables that can influence the outcome, but what you do in a scientific experiment, you hold all but one of them constant. You control all of them except for one, and you just vary the one. But for somehow, they're not getting that.
No, but you just did two experiments, George.
Yeah, you did two experiments.
You just did two experiments.
Yes, but Pete, the whole point is that those two experiments and the hundreds of experiments that have been done related to that, confirming that your temperature gauge can measure temperature, that your pressure gauge can measure pressure accurately, and all of those things are a stream of scientific experiments which contain hundreds of variables, not just one.
Right. And you're isolating the one. What's the hypothesis here? What are you trying to test, Barney? This is what we have to hone in on. So sure, you might have to go through different processes, isolating different factors, but ultimately you can do one experiment at one time, right?
Yes.
Well, that's what you do.
There are parts of the scientific method which are not establishing causes and effects. That's where Riley is wrong, where he is invoking the independent variable as a necessity in establishing cause and effects. I agree with that. But he's saying, and everything else is therefore pseudoscience. That's rubbish, because there are things like measurements and observations and acquiring the data that you can then use to establish those things.
I absolutely agree with you. I absolutely agree with you, Barney. I really do. And I did make these objectives quite clear to Nathan Oakley, Quantum Eraser, Anthony Riley, and crew. So I absolutely agree with you.
And like Riley's answer to me was literally verbatim, "Oh, that's just an observation. That's not science. That's pseudoscience because you do not have an independent variable."
That's right. They won't accept observational science as science.
No, observations are one thing, but the correct interpretation of what you're seeing is a different thing. And this is where we all differ, right? So you don't need to bring those people in here anyway, George, but the point remains the same. We all adhere to the scientific method when we're trying to find out anything in a scientific sense, or at least we try our very best to, but we know that certain things absolutely come outside the scientific method. Nathan Oakley.
Well, the thing is what we have found over the months is that both Quantum Eraser, Nathan, and Riley, they're not very bright boys. They really don't understand this stuff.
Why do you say that?
Oh, they're very bright, George. They're very bright.
Well, they're either very bright and lying and purposely deceiving, or they're not very bright and they just don't get it.
They're actor agents.
I don't think
why do you bring them into this conversation?
Yeah, we're talking about scientific method, not them. So.
Well, Pete was mentioning it, so I just thought I'd bring it up.
Well, I asked you for a specific experiment that has deduced cause and effect relationships, which hasn't stringently, a specific one, that's why I asked, that hasn't stringently adhered to the scientific method.
Okay, so here's the deal. Those guys are the ones that are literally just taking the scientific method and rewriting it, so to speak. And they're preaching this to a lot of people who don't understand it. How do I know? I was one. And I'm still one. I don't really understand much of this, but that's why I have these so people can explain it.
Well, they have citations to show that, as far as they're not rewriting it. They're just showing.
What they're doing is they're taking words of these citations very literally and misconstruing things, just like what they just recently did about using Google Earth as a flat Earth model, where they take elevation and they take drop, which are two different concepts measured from different reference points, different datums, and they're putting them together in a way like mixing apples and oranges that make no sense. And what they're doing is confusing people.
And that's why I said keep it simple. I love that. Yeah. It's just basic.
But George, would you agree that there's someone right and someone wrong here? Either you're right.
Okay,
I'm
okay.
right.
I don't want to get into those semantics. That's what I was trying to stop. No, stop. No, Pete, stop. No. See, you're getting me worked up. This is what I didn't want. I don't want you driving this.
Why
No.
you mute me? I was finished my sentence. For
God damn it, Pete! Shut the fuck up. Don't talk. Don't talk. You've talked for past 15 minutes straight. George has jumped in when he could, like a jump rope. And damn, George, I know you're kind of old.
What are you doing here?
I'm not trying to say God damn it. I'm trying to keep myself calm by having a conversation with George while I'm yelling at you. Thank you. And I just want you to know, Pete, is I want everyone to have something to say about this topic. Everyone has questions, Pete, and you're the only one asking right now.
Well done, Q.
Thank you, Q.
Yeah, thank you, Q.
I'm good.
I'm here for the positivity and the lulls, guys.
Good.
Yeah. All hail Q.
No. Wait. I don't know what to do. Wait. I can have multiple gods. Perfect. We're good.
Yeah.
Okay. Q and Barney, my new gods. Thank you.
Hey, Sean. How's it going?
Hey, how you doing, Gary? I was kind of worried. I didn't know if I had to pick between gods or something. Whew. You two don't make.
I'm not a jealous god.
Okay. Barney? You're not.
So I got a question. It's off topic.
What's up, Gary? What? Huh? I don't know. Hey, everyone. Anyone?
No off-topic things. We're talking about the philosophy of science here.
Yes, we're gonna keep it on, but you can ask questions. Just gonna calm.
I mean, it's about moon phases. Is that off topic?
Let us get through a little bit more, a couple of terms, and then seek and find. You got the floor. I just want to. Here's the thing. I've been trying to do this for 3 days, and it ain't worked, but it's gonna work. Because I need to understand some shit.
John, I have not been able to watch the whole stream. How many terms did you actually get through?
I've gotten through none.
Oh, wow. Okay.
Come on, guys. Let Sean ask his question.
Okay, so actually, I'm going to share this.
Barney,
I mean, there's a list and everything, so I mean, it's and the best part about this list that I've seen so far is that Barney doesn't agree with it, so hail Barney. And then no one's pretty much said differently. I know George, if you saw something in what I was looking at, or what Barney had said before, you probably would have said no. But so I'm pretty sure you agree. So now, but what's very clear to me is even in the quest for definition, especially of these certain terms we're looking for, it's still going to be situational, right? That's pretty much what I just learned, right? I'll take that as a yes.
Yeah.
I don't know what the question is.
Okay.
instances that you're putting up here.
Yeah, you're okay. Oh shit. Okay, my bad. So, I mean, obviously, you know who Riley is, and Quantum Erase. I mean, that group you guys were talking about, how they just mix all. They don't know the terms. Like, they don't understand it. Personally, I've gotten into it with Riley now because, to me, gravity is a force. F you if you don't believe it is, because I'm a caveman. Fuck you. That's how I explain it. But he's been on this tyrant, obviously, about it, how it's not a force and blah 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 blah. But he doesn't understand that Newtonians, they're like, all that shit's used with importance. Like, it better fucking work. And they use it, and he just glosses over it like it didn't ever happen.
Yeah. Yeah, you know, Newtonian mechanics in computing orbits for satellites and rockets that have worked perfectly fine without invoking Einstein's general relativity. Newtonian mechanics works very well for our everyday uses here on the Earth and also in space.
And which means, sorry, Riley, it's a force.
Yep.
Well, there's like some citations that say that it's not a force, and then there's also some that states that there's.
Well, that's a misunderstanding, and I don't think we should really go into that, because that really takes a lot of mathematics to discuss the general relativity. I can tell you the results, but I can't tell you why, without the mathematics, as to why we perceive the bending of space-time as being a force.
But George, it doesn't matter though, because check this out. I have no fucking clue. That's why it's a force. Fuck Einstein. I don't need him. No, but for real though. And I see what you're saying, George. But Howard, the best way I would explain it to you is up until your understanding of, or whatever you can understand. Someone's clinging and clacking in it. Right
Sorry, that's my tea.
Oh, I knew it.
Sean, I'm trying to draw a picture of bendy space-time.
Actually, I'm going to talk, and then I'm going to do some terms, and then seek and find, because I told him. But hang on. The best way I can explain what I'm saying, Howard, is like, it's like I don't understand space-time, so I don't have to go there. And because I don't have to go that deep into gravity, then it's a force, because it works. I'm not doing anything that has to do with Einstein's general relativity, because my knowledge isn't there yet anyway. But hopefully one day it will be, and when it does, I'll understand it to be something differently, and then it may no longer be a force to me. But I'm done.
It would just be a phenomenon.
John, when you're in a swimming pool and you're just floating there, what is gravity doing to you? If it's a force to you, how does it? I think it's best to think
it's acting again. It's acting with the buoyant force.
Yeah, but you know what I mean. I think we have to reduce everything down to try to.
No. Pete, don't. Please don't.
I appreciate that.
Pete, when I say something that's correct and no one says no, I love to just stew in it for a second. You can't just bypass it like that. You can't just bypass it like that. You asked me.
Your body is made of 70% water.
You asked me a question. You said, if you're in water, blah blah blah. I said because the buoyant force and gravity, and I was correct.
Right.
Boom.
It's like you're not going to change his mind. You just
hang on, Sean. You know your body is made of 70% water, right? Would you agree with that? And you
yes,
see
sir.
That comes into effect when you're in the swimming pool and you're considering gravity.
Dude, it's not made out of 70% water like a glass of water, though, is it, Pete? 70% of the glass of water is water, and the other 30% is the glass, dude. That's not a human being.
That's true, Q. This is what's generally, just when we consider it.
Well, let's try not to be exaggeratory and ridiculous.
Yeah. Well, I don't want to be talking about any of this stuff, Q.
Okay, then Pete, I have a good idea.
And let other people talk about it, Pete.
The panel's full. Why don't you jump off and let someone come in that has questions, so that your boredom doesn't derail shit.
It's not boredom, but I'm just saying.
But wait. You didn't deny the important shit. Well, the part that where you interrupt.
Answer my question then. So you don't appreciate, and I appreciate that. You don't appreciate. You can't imagine space time. What's going on? They say this is the cause for gravity, or you can only appreciate your natural life, right? So when you jump,
you're doing it right now, dude. You're doing it.
You drop.
I can't.
So when you're in the swimming pool, what's happening? This is what I'm saying.
See, like,
you want to borrow my red button of death, Sean?
I'm about to.
Take it easy. Fuck's sake. I'll do my own hangout. Come over to my own hangout for a bit of interesting conversation, for fuck's sake.
Pete, why don't you listen a minute? What Sean is trying to tell you.
Thank you, Pete. Thank you. Appreciate it. Bye. Have a good day.
It's that clash of people. I told you. I know it now. That's why I did the one-on-one with Pete, guys. I'm not stupid. I'm telling you. You guys were like, he's crazy. Why? Because I want to hear Pete and Pete.
Well, Sean, I think what was
one-on-one.
I think what was going on here is Pete just wasn't listening to you. I mean, what you're trying to tell Pete is that, for our everyday life, for most of our experiences here on Earth, Newtonian mechanics works perfectly well. And to describe gravity as a field that presents itself as a force on material objects is perfectly fine. We do not need to invoke Einstein's general relativity to solve these problems or to describe our experiences. The only time the general relativity theory of Einstein comes into play is into very esoteric, very precision measurements and situations like with the global positioning system. You have to take into effect some general relativistic effects. But for 99.999% of our experiences here on Earth, Newtonian mechanics works perfectly fine, and to describe gravity as being a force is perfectly okay.
And it's the easiest way to explain it.
So even if you take, and that's the thing. Yeah, that's kind of a problem. Even if you take into account general relativity, from the standpoint of general relativity, in Sean's local point of view, in his local frame of reference, gravity absolutely is a force. Right? He is in an accelerated frame of reference, and yes, there is a force acting on things which are stationary, which accelerates them in a single direction. That's a force. That's the definition of what a force is.
This is why Barney is my guy, because that fucking lighter is the shit. Like, if all the lighters on Earth were gone,
that lighter is the definition of gravity.
Yeah, if all the lighters were gone on Earth.
Well, the thing is, you picked it up and put energy into it.
No. And I've been able to bypass that, because if the floor,
you have to keep in mind, the thing that you need to keep in mind is Newton's first law of motion, that an object at rest will tend to stay at rest, or an object in motion will tend to stay in motion unless acted upon by an outside force. So if you see something move or change direction, it means that there is a force acting on it.
And
which means that you picked it up.
No, Howard, here, but I figured out a way.
Yes. That lighter was moving up. You imparted a force to it in moving it up. Then you released it, and you are no longer acting on it, but the force of gravity is.
Barney, put your hands under
it. Is this lighter stationary?
Yes.
Is it stationary?
Yes.
Is it standing still? Until you let it go. But if you picked it up.
Wait, am I supposed to count the rotation of the Earth?
Hang on, sorry. Watch this.
Will it start moving? I'm sorry, one more time. When I let it go, will it start moving? Yes, because you put it in that position. You took it out of equilibrium. Yeah, but it's in that position. It is stationary. It does not have any velocity. It does not have any acceleration. And when I let it go, it acquires some acceleration, which gives it velocity. And the thing that gives mass, such as a lighter, acceleration, is by definition called a force. So yes, there is a force there. There's a force, but you're calling it gravity, but you don't know the cause of gravity.
Look, Barney, put your hand under it.
Okay,
Barney,
so
can I show you that? Can I show you?
I know that's a phenomenon, right?
We know the cause of gravity on Earth as we experience it.
Howard, we do not need to know the fundamental nature of gravity. We don't know the fundamental nature of the electric force. We don't know the fundamental nature of the magnetic force. We don't need to know them.
Yeah, but you agree that pressure is a force, right?
So you can hang on, guys, because I've been trying to say something to Howard. And everyone's kind of just jumping all over it. Like check. See, yeah. Go ahead.
Pressure is a force.
Completely forgot.
Right.
Never mind.
And y'all claim that gravity is the cause of
about the transfer of energy because he puts in a position, Sean.
Yeah, but I completely lost it.
So right now the lighter is what?
Oh, thank you. God damn. Okay, so you said he had to pick up the lighter to put energy and then drop it. Barney, put it on your hands under it, please. Both hands, and put it in that crease. All right, it is at rest, sir. Am I wrong?
It's trying to find a floor. So
okay.
Barney, so yes, it's at rest right there because he put it there.
Can you?
Why is it trying to find the floor? Why isn't it trying to find?
That's fine.
Base?
That's fine. That's fine. Let's pretend it's on the floor. It's on the ground. And this happens. We know. What if the Earth were to split out from under it very quickly, Barney? He didn't have to put a force into that. He didn't have to drop it. He didn't have to, huh?
That's the cause.
No,
then.
But if the floor, if the ground, the Earth splits from under it, what force then has made it go down?
It's a phenomenon. We don't know if it's a force. We don't know what it is.
No, it is a
phenomenon. That's you. That's you. You don't know what it is.
The definition of what a force is.
We don't know what it is. It's trying to find equilibrium.
No, that is the definition of what a force is, right? If you're saying we don't know what's causing it, I'll say fine. I know, but Sean claims he doesn't because he doesn't understand Einstein. That's fine.
Sorry, right?
But the force is there. The force is there because you've seen something stationary start to move, trying to find the floor. I'm fine with that. I'm fine with its relative density. I'm fine with that as well for the purposes of this conversation, right? But there is a force that is pushing it down, and we call that force gravity.
Yeah, again, we're back to the first law. This lighter started from zero velocity to some other velocity, so its velocity changed. It changed its motion. Hence, there has to be a force present to cause that change of motion.
And that's why I like the whole put your hand under it thing. Because then you're not.
And when we try to identify things, like we know it's a force, it's by definition a force, but when we're talking about force of buoyancy and force of that and force of that and force of that, we make up words to identify individual things so we can talk about them. And the word that's been made up for that force is? Anybody?
I call it
I was just giving everyone else a chance.
Okay, so then what about a balloon?
I are choreographed.
Let go of a balloon. Then what?
Say again with the balloon.
So you're holding a balloon, right?
Yeah.
You let go of it. Where is it going to go?
Up.
What's it full of? Is it full of helium, water, full of air? What's the balloon full of?
It's going up. It's going up when you let go. So is that anti-gravity?
No, it's gravity.
I know. Hey, time out. I know how to do anti-gravity. You ready? Everyone can do it. Ready? Jump. I said it first.
It was the lag.
Yeah, you're right. My bad, God.
Anti-gravity would be like just being suspended in space-time without being forced up or down in any direction.
Well, it would be the opposite of what it's doing. You have to jump.
That'd be weightlessness.
You're going against the.
It'd be as if weight doesn't exist. That would be anti-gravity.
Howard asked, how does gravity cause the helium balloon to go up? Right? Because the same gravity is acting upon everything in that space, including the air. And the air is heavier it has more mass than the balloon. So once they come to the same level, the force on the balloon and the force on the air are not the same. The force on the heavier thing is stronger. It is proportional to the mass. So that air is going to go down and occupy the space below the balloon, and it's going to squeeze out the balloon up, right?
So basically you're saying density, so it's less dense than the air around it. So it's going to.
No, that's not what he said. He's describing buoyant force to you, and you just thought it was.
No, that's in a different medium. Buoyant is.
No, because he just explained gravity. It's just like if you take a basketball and you force it underwater, that water is going to squeeze the basketball on either side, pushing it upwards until it's relieved of that pressure. I don't know how you heard density in that.
Because it's more dense. So basically it's trying to find equilibrium, correct?
Yes.
Yeah. So you are putting force into that basketball going in a pool, let's just say in the pool. You're pushing against the pressure because once you let go of it, it's going to try to find equilibrium. So it's going to move up. So that
why up?
See,
why? Yeah.
Why up?
Yes.
Because it's seeking equilibrium. That's it. There's no force.
Why isn't equilibrium to the right?
What's that?
Why isn't equilibrium to the right rather than up?
Because you didn't force it that way, maybe. I don't know. I have no idea.
Yeah.
You could be going opposite of the force.
I want to say it's
the problem with this buoyancy density argument is you don't know. You don't have the answers.
So
density doesn't dictate direction in any way.
Yeah, but there is direction involved.
Yes.
The reason it goes up is because the direction is in the direction of the gravitational force field.
The heavier thing will go in the direction of gravity and squeeze out the lighter thing up. And that's why less dense things go up. There is also, I've been telling this at the beginning of the stream, there is also buoyancy acting on me now, and I'm exactly, if you put me on a scale, my mass, my measured weight would be exactly diminished by the mass of the air that I'm displacing. Because the air is trying to push me up as well.
The air is pushing you up on a scale?
Yes. And if you stand on a scale in water, it's going to read less. How much less? Exactly as much as the volume of the water that you have displaced.
Yep. Every object in the atmosphere has a buoyant force on it. It might be minute, it might be small, but there is a buoyant force always present on every object.
And if that buoyant force is greater than the force of gravity, then that thing will go up.
And the buoyant force is determined by Archimedes' principle, which states that the buoyant force is identically equal to the weight of the medium that is displaced by the object. So, say you take yourself a cubic foot basketball, and the weight of the air that would be inside that basketball is the buoyant force on that basketball. What Barney has said is that if that buoyant force is greater than what we call the free space weight of the object, that is, if you took that object and weighed it in a vacuum, that weight never changes in the atmosphere or any medium. What changes is the buoyant force. So you have two forces acting on your object. There's a buoyant force tending to push the object away from the Earth against gravity, and you have the weight, the free space weight of the object trying to move the object downward. So it's the balance of those two forces, or the difference of those two forces, that determines if the object's going to move up or down. If the buoyant force is greater than the gravitational force, the object moves up, like with the helium balloon. And if the buoyant force is less than the free space weight or the gravitational force, of the free space weight of that object, the object will fall towards the earth. It's just
do you agree that
forces.
Do you agree that pressure is a force, George?
It's a force per unit area. It's not just a force. It's the concentration of force over an area.
And what's causing that force?
Well, it depends on what the medium is. Usually in the atmosphere, that pressure is caused by the weight of air above you or any other molecule of air at a given height. All that air, the weight of the air above it, is what causes the pressure. It's the weight of that air pushing down.
So when you're inflating a balloon and you're creating more and more pressure in the balloon, the force is coming from your lungs being compressed by your muscles.
Yeah, and it's counteracted by the skin of the balloon trying to compress the air. The tension on the skin of that balloon is what helps create the pressure inside the balloon.
So it's not gravity causing the pressure. It's the density of the air column.
That's the predominant one, but gravity is also causing a slight pressure difference between the air at the bottom of the balloon to the top of the balloon. There is a slight pressure gradient within that balloon, but it's ever so slight that's probably unmeasurable using common pressure gauges.
So you put in two different forces then. You put in the pressure force, and then you're also saying gravity.
Gravity causes the layering of the air, a stratification of the density of the air. You have the weight of the air pushing down on the air below it, which causes a slight increase in pressure at the bottom of a container versus the top. Barney can maybe...
So, by definition, a gas is a state of matter which will spread out indefinitely until it fills up available space, right?
Yeah, how's that being maintained is the question.
By gravity. That's the whole point.
But it's not a force, though.
Right. If there was no
yes,
gravity,
it is.
The molecules of air would collide against each other and ricochet in all directions and just go in every direction until they either find the edge of the container or go away, roam free, right?
So how's that
unless there is a force pushing them down, right? If it was just a container, then there would be no relative density. There would be no density gradient. There would be no column, right? Because it would expand in all directions until it reached equilibrium.
Yeah, but this is a dynamic system, and there's also a lot of different factors going on. There's, you got temperature, gradients everywhere, and then you also have a voltage gradient. The electric potential gains as you increase altitude also. So this is a dynamic system, and I think the gas molecules are being influenced by. Hold on, John, I'm not done.
I don't understand.
The electric potential gains. Is that what you're talking about?
Yeah,
it increases.
That part.
As you gain altitude. That's also going on.
Okay, so when you significantly disambiguate the positive and the negative charges to create that voltage, what happens?
Do you agree that there's another gradient also, though?
There is many.
Right.
Yes,
That's what I'm saying.
The world is a complex place, no doubt about it, right?
Agreed.
And we're trying to figure out what the kind of the simplest elemental things we can isolate and identify as individual contributions to that complexity of reality that we're seeing, right?
Yeah, and not only that, what you have to do, you have many factors that can influence, say, your pressure or something. Some are more predominant than others. And in engineering and physics, we oftentimes try to identify what we can neglect. The effects that are insignificant in order to make the problem tractable to solve is you eliminate the factors that are rather insignificant in influencing the outcome. You don't need to consider them. For example, if I want to know how the air around my house or the pressure if I want to conduct an experiment, I don't need to consider that butterfly a mile away flapping its wings, though it does influence the pressure at my spot a mile away. It's so insignificant as to not be able, as me not having to take it under consideration, because we're probably talking its effects are on the order of parts per million or parts per billion. It's insignificant compared to the experiment that I'm conducting. So, you just make engineering judgment calls as to what's significant and what's insignificant, what needs to be considered and what doesn't need to be considered when you are trying to analyze a particular problem.
So the pressure's being maintained by a force, yes or no?
Yes.
The weight. Well, the pressure of what?
Well, I mean, Barney, you said before that you didn't think gravity was a force.
But I told you it is the whole time, homie.
It has to
gravity
be a force
being a force.
For all this to be going on a ball. You need a force. You need a force.
Seek and find. I have very, very qualified that statement. So there are ways in which it is a force, and there are ways in which it isn't. If you're measuring within a local frame of reference, which is accelerated upwards, yes, then gravity is a force, right? That's what gravity is.
How can you have both ways like that? Like in every other practical, explanation,
so you can find
a
like
force
this.
has effects. You know what I'm saying? We see
so
that.
Fine.
So.
Look at your hand.
No,
look at your,
no.
I'm gonna show you right now. Look at your hand. Look at your hand. Boom. That's how gravity is.
We're talking about
it's a force.
Talking about gravity holding and maintaining the gas pressure. Like, how is that possible?
And holding the water that's magically sticking to a ball.
Gravity is the container.
Okay, so how do you demonstrate that?
Everything, the pressure gradient.
The pressure gradient.
The pressure in order to have a gradient, correct? So therefore, you need something to press.
Wait. No. The pressure having a gradient curve.
That's the other. No.
Am I wrong? Maybe
what
it's
you're getting. What Howard's getting confused at, Sean, here again.
What am I getting confused at?
What establishes the pressure, air pressure, that we experience on the Earth or above the Earth has to do with the weight of the air above you pushing down on the air beneath it. That's what creates the pressure. Think of it this way. Are you familiar with bats of insulation that you put in the walls of a house? Fiberglass insulation. Say you have these bats of insulation. Say you have 200 of them. You fluff them up and you start stacking them up. They each have the same density to begin with. As you start stacking them up, the weight of all the bats above the ones on the lower ones are going to start compressing the lower bats of insulation to where they're getting thinner and thinner and more dense. The volume is compressing on these things, even though each bat has the same amount of matter or material. The density is increasing because what's density? It's mass per unit volume. So the volume on each of these bats are decreasing on the lower bats with the weight of the higher bats pushing down on it. That's how it works with the atmosphere, with the air in the atmosphere. And what gradually happens is this pressure decreases to the point of where it just feathers out and merges into what we consider the near vacuum of space. There is no container needed. The weight of the air holds itself to the Earth.
Next to a vacuum where it's void.
Yeah,
but there's no pressure next to a vacuum. This is the whole problem with
George. Barney just
racer argument. There is no pressure next to a vacuum.
Barney just told you that the gas is trying to expand outwardly in all directions. So
yes, but it's being tethered to the Earth by the gravitational force on each of the air molecules.
So gravity is a force.
Yes.
Yes. They keep saying gravity is a force, but you have demonstrate it. Demonstrate that gravity is holding.
Yes. Yes. Yeah. Knew it was coming.
Look around you.
So
No, so practically we can demonstrate over and over that you need a container of some sort, but y'all can't practically show us, a force maintaining pressure.
Doing that, dude. You're doing it. Dude, we just explained it. Barney, do it again. Thank you.
Where's a container in a tornado where the air pressure inside the tornado funnel is 2 to 3 psi less than outside?
It's a dynamic system. Agreed. We're talking about maintain pressure. You're going to wake up tomorrow, the pressure will be there. That tornado might not be there tomorrow, but the pressure that you're breathing is going to be there tomorrow.
Okay, how about an air tire?
We're talking about maintaining the pressure.
Let's talk about this tire of a container.
The gravity's still there.
Gravity.
Right.
Yeah, so this force, right? It shows effects. What's the effects that the force is showing? Because all other forces show effects on things. So what's the effects of
Hey!
Okay, Barney. Okay, Barney.
Effects.
Barney. Say we got Okay, I got a question for you. Say we got a still body of water. What is the effects of this force on that still body of water?
That body of water will take up the container and as though it's being compressed
and level out, right, and be flat on the surface. Yeah. So gravity, this force is making level liquids flat on the surface.
Yes, in the direction of gravity.
Not flat, level, not flat,
level.
Yeah, but the surface of it, because it's level, is flat, right?
No, it's not. No, it's not.
So what is it?
Water. It's all wavy and shit, dude, but it's pretty much the same height all the way around.
A still body of water, right? When it levels out, when it becomes the container, it shapes to the container, becomes the container. When it levels out, is it?
It is not flat.
By nature of it leveling out, George, is it flat on the surface or what is it?
I just said no. It is not.
So what is it? I want to know what it is according to you.
It's spherical in shape.
Demonstration.
Well,
it's level.
Watch some of my videos. I actually measured it on a large body of water.
Gravity is a container, but you can still go outside of it. That's my understanding, right?
Not really.
It's not a barrier, right?
Go out of space, right?
No.
So
no.
There you go.
You can measure the spherical surface of a large body of water. I've done it. I have some videos on it. I measured it with a set of very precision surveying equipment. You can get the 8 inches per mile squared.
So you, for the record, you're saying that a level body of water is not flat on the surface?
Not on the Earth. No, it is not.
Not on the Earth.
No.
Not really anywhere.
Yeah, not really. Water's pretty wavy.
Have you guys ever heard of float glass?
Heard of what?
Float glass. The production of float glass. You ever heard of it? You share my screen, Sean. I'll pull it up. You know what I'm saying?
Yes.
I know what float copper is. I'm not sure what you mean by the term of float glass.
That sounds like the same thing.
It is pouring out glass on mercury, if I'm not wrong, to get
a still fluid, a body of a still fluid, and they come out completely flat. I'm just trying to say that
wait.
What's the contradiction of what you guys are talking about?
Not perfectly flat.
But how do you determine flatness?
Accuracy is that perfectly flat.
How do we determine flatness?
You all are talking at the same time. So
we're all
what degree of accuracy is that perfectly flat? Can you make an infinite flat plane that way?
So again, by the virtue of it being level, you guys are trying to say that it's not flat on top. So what is it? If it's curvy, the glass would come out curvy, right?
As far as sorry,
I'm sorry, Barney.
No, go ahead, George.
No, I was going to say over small areas, say over a 10-foot diameter area, yes, it looks flat. But if you were to go down with very precision instruments, you would find that the surface is curved as the surface of a sphere.
John, can you share my screen, man?
You can't measure the curvature.
Well, anyway, these things are like 150 feet. And,
that's still not enough.
Perfectly flat glass.
No, there is no such thing as perfectly flat. right? The most perfectly flat things that we can produce are called the tool maker's flat. It's one of the tools for making tools, which is made by lapping three metal plates against each other. And even those, when you make them, they are what defines flat for tool making, which is within the 10,000th of an inch. But it has an error within a 10,000th of an inch.
It may have a very small, slight, so what are you trying to say?
Yes, over a distance of 20 centimeters or 20 inches or something like that. There is no such thing as perfectly flat. There is flat enough, right?
I was just going to say, Barney, he doesn't realize that with the vastness of the Earth, the fact that the radius of the Earth is 6,371 kilometers or 3,959 miles, that over 100 feet, that surface curvature is ever so slight. This 8 inches per mile squared, if you dial it back to something around our own space, that works out to 287 nanoinches per foot squared. Do you know what a nano-inch? That's a billionth of an inch. Okay? 287 billionths of an inch is the curvature that you'd expect to find over the surface of this glass over 1 foot. You're not going to be able to measure that. That's what Barney is saying. It's well within the tolerance of the instruments that you're going to try to measure that surface. So yes, to you it seems perfectly flat, but it's only perfectly flat within the tolerance of the measurement instruments that you are using.
We know. We've heard it all before. Everything's so minute, you're not going to feel it or see it or notice it. We know.
Yeah,
we've heard it all before.
Nazis, it's sufficiently flat. It's flat for all intents and purposes of what you can do.
Flat? No. Not perfectly flat, but sufficiently flat.
All right. It's flat, man.
It's flat. It is flat.
Yeah.
Every curve. Right. As you take any curve whatsoever, and take smaller and smaller and smaller and smaller and smaller chunks of it, you will be approaching flatness. So if you take a minute element of any curve in the universe that you care to measure, its smallest part will be sufficiently flat.
Yeah, I think that's the term we need to use, Barney, is let's not say flat, let's say it's sufficiently flat or approaching.
Everything that you care to do in reality will be an approximation. There are no circles in the universe. There is no such thing as an actual circle in the universe. Everything is an approximation, more or less, to the ideal thing, which is ideal because it is explained in the simplest possible terms that we can think about, where the sum of all points around a single point is a circle. There is no such thing in nature. There is no such thing as a perfect circle. There is no such thing as a perfectly flat surface.
Yeah. No, if you take a body of water, if you try to measure the curvature, say, over an area that extends out a foot from you, you're not going to be able to measure it because, like I said, you're going to be looking for a deviation of 287 nano-inches, billionths of an inch. However, if you go out a mile, it's going to deviate by 8 inches. You have to get out sufficiently far distances before you can start detecting these curvatures on the Earth because the Earth is so vast.
Yeah, but if level water was curving, it wouldn't be level. So
it is. That's what we mean by level. You don't understand the terms in terms of engineering, physics.
Right. Because it's so hard to understand that.
No,
level and flat are synonymous.
No, you are. This is the problem that we have with terms. You don't understand the scientific engineering meaning of the term. You're using you're using it in a layman's sense. If you
God damn it, George, you've been talking for like 15 minutes.
What?
You interrupted Barney, who was like on a roll, to bring everything down, and then you've been talking for like 5 minutes straight.
I'll let him. He's. I like what he's saying.
This is my opinion.
I'm just trying to tell Seek and Find here that he's using level and flat interchangeably. It is unfortunately done in the layman vernacular, but in the strictest
not always
sense of the term, no, in engineering, science, and surveying, level and flat mean two different things.
You're correct, but say I go buy a laser level, and the laser that shoots out of the level, is it a straight line?
No.
A laser beam is not a perfectly straight line.
Golly.
For all practical purposes, yes, it's straight for all practical purposes, but it does deviate. And not only that, it goes out in a cone. It does not remain central thin.
I may be able to help you guys here. I have a PhD in Seek and Find.
Okay. So can I get to my question? Because I had a different question.
Yeah, I know. That's what What's up, buddy?
Can you share my screen?
Yes, I can finally share your screen. You shared my link. I'm just kidding.
My bad.
No, I'm just kidding.
Everybody can see this?
Oh, wait, didn't we do this already with somebody else?
I'm this to him in the side chat. I will let Barney field this one. This is ridiculous. I went through this with him in the side chat earlier, but
but this is kind of, it could be for everybody. That's fine, because I'm kind of asking the group. Does everybody agree with this diagram right here? We're talking about moon
phases. Are you going to ask us how we have waning crescent or waning or waxing crescent in the day?
No, that's a daytime moon according to this diagram right here. You agree, right?
I'm just checking to see what you're going to say. Go ahead.
You agree, right?
Hey, I'm just going to let you know so you can find it. I'm going to let you know now. This has already been presented on this live stream, I think like yesterday. But go ahead.
Okay, if I would like to hear the explanation. It's fine. I'll concede if I'm wrong, but I would like to hear the explanation. Okay, so everybody agrees with this diagram, right? Daytime moon. I mean, the reason for the new moon, right, is because it's the angle to the sun, and it's being, for the daytime people trying to observe the moon, it's being blinded out by the sun rays. Correct?
Yeah.
So that's pretty much the same reason for these crescent moons right here, right?
Yes.
Pretty much the same reason that we have a new moon is the reason we have crescent moons, correct?
Yes, the same effect, yeah.
Right. So
you'll see it though.
Observing a crescent moon in the nighttime for a nighttime observer right here will be a contradiction, right?
Nope. That's why you see that small line. That's why you see a thin line.
So
hold on.
Yeah, okay.
The reason for these gibbous moons is because of the angle from the sun, and it's in the nighttime sky as this is depicting.
Yes, but
right.
Well, you have to look at your angle. If you're in the dark part on the left-hand side, look at the terminator. Draw a line from the terminator, that is
exactly
where the light and dark are, over to the waxing crescent, and you will see just a thin part of the lit portion of the moon. That's what we call the crescent.
So from the daytime, right? In the daytime, these are all daytime moons, correct?
But it doesn't matter. Look,
no matter the angle. Look. Hold on.
You can see the waxing crescent from a portion just after sunset in the dark portion of the earth. That crescent moon, that waxing crescent, if you watch, only remains in the night sky for about an hour or so, and every day it increases by about 45 minutes, the length of time that you see the crescent. But the first time you see that crescent, it will only be in the night sky for about an hour, half an hour.
It should be going into like a first quarter moon, correct?
Hey,
Sean, would be like the sun.
Can you present me, please?
Moon right here. Now, hold on. I'm not done, Barney. Hold on. You still present me?
Yeah, you're still presented.
Yeah, y'all agreed that these are daytime moons because of the nature of the angle to the sun.
Yeah.
So when we see moons like this,
Damn.
Yeah.
I was actually getting kind of pissed off at you, so you can find too. Damn.
This moon right here is at 9:30 at night.
Yeah.
As you see, 8%. 8% of it is lit up. This moon is being backlit right now.
Yes.
Correct.
When you say 9:30 at night, when was sunset?
Where is that at?
Yeah, I don't know when
was sunset.
But
I can't see that.
That's fine. This is the
year at 9:30
That's all I'm pointing out. Let's go back. Look.
Until
daytime moons.
Yes.
Again.
This is not during the daytime, fellas. This is during this moon. If you just think about it, this moon is being backlit. The sun is lighting up the back side of this moon and the other half of the earth. That's behind this observer.
Do you care
to its moon in the daytime? 68%. Look, this is at 2:30 in the afternoon. This isn't during sunrise, fellas.
Hey,
this is at 2:30.
Can I show you something?
Again.
Yeah, I'm gonna present real quick. I want to show you something. You ready? Ready for this?
God.
This is my special gift to you, so you can find. See that? See it? You're talking about, right?
I had a better picture, but
yeah, but that's what you're talking about.
You're trying to.
No, that's not what he's talking about.
I had a better picture. I don't know why you're trying to go find another picture. I had a picture of a gibbous moon in the middle of the day. That is a contradiction to you guys' model.
That is what this is. But there's a difference.
That's not a gibbous.
Which one is this one?
I don't understand what the problem is with the gibbous moon in the middle of the day. What's the problem with
it? My next one, because I have others.
But
the point of this whole thing is those are mine.
If you pull up, all you got to do is pull up the phases of the moon. The reason for the phases of the moon. The new moon phase, the reason for it is because of it's a daytime moon and it's being blocked out by the sun rays. That's the same reason for seeing a crescent moon. It's a daytime moon. All you got to do is look at
the because of
phases
those angles.
Of the moon are the effects of the moon causing a shadow upon itself from the sun being on one side or the other.
All you got to do is look at the diagram. It's a daytime moon.
Okay. Hey, Sean, let me. I think I can field this for him. Okay, let's look at your diagram.
Good, you take it. I'm gonna go get a salmon.
Put your diagram up. Okay. Now look at first quarter and waxing gibbous. Now let's put a gibbous moon in between the two. Okay. It's not showing it. Put a gibbous moon between waxing gibbous and first quarter. Now draw a line from the 1 o'clock position.
George, I'm just trying to do that.
Yeah, that's what he was going to do.
Okay.
That's why I'm sharing his screen now, because I knew that's what he was doing. He was trying to do it first.
This is your diagram. Let's take a person which stands here in the evening of his day and see where his horizon is. Right? The tangent line to his position is somewhere like here. And in the evening or early in the morning, he can actually see the waning crescent at night.
Yeah, but your claim is that it would be during, sunset hours. I'm showing them in the middle of the night. Like that gibbous moon in the middle of the day is at 2:30, Barney. It's at 2:30.
Yes, I'm calling bullshit on that. You can see somewhat of a gibbous.
Is
so it is a contradiction then. It is a contradiction. It is a contradiction because you call it bullshit.
No,
this point can't happen on your model, right?
Wait, the difference is you will never see a thin crescent at this time of the day.
Yeah, look, if this point is the noon, then let's say this is 2 p.m., right? It's still going to show you some of the gibbous on the horizon at 2 p.m. Right?
Yeah, but see, daytime, right? It's supposed to be increasing, right? The how much you're seeing on the moon is supposed to be increasing that because of that angle, correct?
Daytime, it's supposed to be increasing because of the angle.
What are y'all doing?
Showing my pictures of the moon.
See, the thing you're missing here, so you can find, is the thin crescent. You're only going to view for an hour or so after sunset, and then that crescent moon will set. As far as the gibbous during the day, yes, you will see the gibbous because you will be at in the diagram there. You'll be around the 11 o'clock position on the moon, and you can see it from the lit portion of the Earth.
George, in the chat earlier, you said the gibbous is a nighttime moon. Did you not say that?
But it is.
It is.
Okay, so I got it caught at 2:30 in the afternoon. This is a gibbous moon.
There's two types of gibbous. There's waxing and waning. The waning gibbous is
that doesn't matter.
Visible during the night. The waxing gibbous is visible during the day.
So you can find where is that at?
Where's what at?
Where is that observation from?
I don't know, Sean.
Kind of matters.
Why does it matter? Why does it matter? No, it doesn't matter.
Don't you see those lines that Barney drew?
Yes, it does matter.
Those lines that Barney drew? That's why.
Because the moon is rotating on a different axis than the spin of rotation of the Earth. If you're taking the measurement from the North Pole during summer, right? You will be able to see the moon for technically any phase.
You don't have to go into that. You don't have to go in. So basically, what you guys are saying is, the person didn't take this at 2:30 in the afternoon.
You know for sure.
It's got to be bullshit, right?
Wait.
No, it doesn't have to be bullshit. It doesn't have to be bullshit.
Did Sandra tell you she took that picture at 2:30 in the afternoon?
That's what the timestamp says.
No. It can be
video.
That's when it's uploaded.
How far north was she?
Huh? I hear y'all both talking. I can't hear you. Look, 14:30, 2:30. Daylight moon.
Yeah.
Yeah, 68%. That's past the half moon phase. This is a gibbous moon in the middle of the day. That's a contradiction to this diagram.
No, it's not.
Okay, I mean, if that little angle you drew from way over here trying to see a gibbous moon, if you believe, okay.
Go do it yourself. Check. You can do everything you just did. You can verify yourself.
I see. Look,
hold on.
You would have to say, hold on.
This guy is geometry challenged. Maybe we should move on to a new question.
Yeah, look, you would have to say that that's either during sunrise or sunset. It's not during sunrise or sunset. It's in the middle of the day.
No. It can't be at the middle of the day. She just needs to be in summer on the northern hemisphere, or in summer in the southern hemisphere. It has to be taken during the summer, right? Because of the tilt of the Earth.
Yeah, you're not taking the tilt of the Earth into consideration here, and plus the moon orbits the Earth at a 5-degree angle to the ecliptic. These all are factors. This simple 2-degree diagram fails to show you all the other subtleties that enter into this.
So you disagree with the diagram?
No, it's disagree with the diagram.
It's communicating
diagram trying to depict 3D space.
You're learning very well from them, Grasshopper. I'm just saying that the flat Earth argument. I don't know. I listening to you do it. But sorry.
I mean, this is a simplified diagram of the actual 3D system that we have to deal with. You can get an idea, you can visualize what's going on here, but apparently you're having difficulty understanding angles to viewing either a crescent or a gibbous moon when you're near the terminator of the Earth. I mean...
Oh man, what Stingray is doing that needs to be presented, that's perfectly it. Right? Midnight at northern hemisphere during winter, you can see the waning moon because of the tilt.
Okay, yeah, I'm looking at what he's doing. So what phase is that, would you say, that this observer has right here? What phase?
I just want to say I apologize, Stingray, that we're on Hangouts and you can't use anything above 720. I'm sorry.
I know, right?
Okay.
It's annoying. I'll make do. So a guy asked me, I can't remember it was. It was in one of the Discord channels that I never frequent anymore now. But they showed me an image of. He asked me, said, "Well, at 2:00 in London, I saw this kind of moon, and it's pretty much impossible." And they're like, "Well, not really. If you kind of plot where the sun is, the tilt of the Earth, give me the time, I'll put it in the geographic location, and I'll show you exactly." I mean, obviously, the moon is probably about this big and about that big and a long way away. I've just made it big because it doesn't actually alter the shading of it, so that we can actually see what happens on this. So yeah, I can build a model of the phases of the moon, and basically put a camera anywhere you want, and it just matches reality based off one directional light source over here that's illuminating the other side. Now, in this situation in Florida, looking at the moon, I would see this in the middle of the day. I don't know when this would be, but yeah, these are just. This is incredibly easy to figure out.
Thank you for showing this. Another way to do this is get yourself a couple friends. I've demonstrated this in an astronomy class. Is get a spotlight, stand. Take yourself a beach ball and get yourself, say, a softball or a soccer ball, and have someone hold that and go around you that's standing next to this beach ball and have someone shine a light, or even do it in the sunlight. Go outside and do it in the sunlight and look at these various orientations. Place yourself on the lit side of the Earth and the shaded side of the Earth, and you'll see exactly what Dean is showing you and what we see in the night and the day sky with the moon. You can very easily demonstrate these things to yourself. Just go out there and do it. Get off your couch and get a beach ball and a soccer ball and go outside during the sunlight and have someone help you and orient a soccer ball around the beach ball and observe what's going on. Very easy to do.
Yeah, it's something I'll have to do a demonstration of. But Dean, try to get it to. Can you get that observer right to look at a crescent, a sliver like an 8% moon that I just showed?
And Dean, what I need is a flat Earth, the sun that hits the horizon, appears by obstructing, or the perspective of.
I've got a flat Earth that absolutely shows that exact kind of point.
See, this is in the middle of the night. This is not this. Where you're at right now is around sunset. And
sorry.
You cannot have.
Give me a time
you will never see a thin crescent in the middle of the night.
No. Yeah, it's impossible.
I just showed one.
No, you didn't.
So I didn't just show a crescent at 9:30 at night and a gibbous moon at 2:30.
Yes, but when was sunset? 9:30 isn't necessarily.
Okay, so what about the gibbous? What about the gibbous at 2:30 in the afternoon? You gonna ask me a sunset at 12 o'clock?
Yes.
Come on, man. Y'all just the sunset had been happening. This is 2:30 in the middle of the day. 70% of the moon being illuminated.
The thin crescent only occurs for a short period of time after sunset. So you have to consider, like here in the northern hemisphere, after sunset, an hour after sunset would be around 6 at night. Whereas around June 21st, an hour after sunset will be 10:30 at night. It depends on the time of the year.
2:30, middle of the day, broad daylight.
Yes.
And how much of a gibbous is it at 2:30, right? And how far north is she? That's what you can't have a tiny crescent moon at noon, but you can have a significant crescent moon at noon if you're far enough north and it's summer.
Are you going to concede now?
Depends on the time of the year and your latitude.
Talking to me, Sean?
Yeah, of course.
No, I mean, I'm sitting here watching him play around with it, but I'm still not seeing the 2:30 middle of the day gibbous or like a 9:30. We talking about almost 10 o'clock now, going on 10 o'clock. Yeah. It's not during sunset hours. It's not during sunrise hours.
I just witnessed a sunset for the first time in my life.
Yeah, I'm gonna start plotting it out myself because when I see the moon,
9:45 at night.
Yeah, it's something that I'm just I'm keeping my eye on. So I just got questions, man. It's just a question.
No, but you did say you would concede if you were wrong. So if he's able to show you why you see that, then you would say you were wrong.
Right, and I would like to kind of demonstrate it myself because I played around with I think it's called Stellarium or something like that. I played around with Stellarium and looked at it, but every time the moon was coming around, it's going from a half moon phase to gibbous phase. It's never a crescent when it's in nighttime sky.
Because you're looking at it and you're chasing it. You're not seeing what you normally would see. Standing there, you're doing too much. Calm down. Watch it. You can only do one thing.
I'm doing okay, cruising with Jay. I'm doing okay. Just battling my own battles right now, but I'm okay.
Again, I like to say sorry to Stingray that he can only have 720 resolution.
Keep rubbing it in.
It's not your fault, Sean. It's Hangouts. I get it, and I know this.
Yeah.
So,
but I feel bad.
I do too.
How do you stop screen sharing? I'm still screen sharing.
I think it's you should be like a little blue box somewhere on one of your screens that says sharing. You hit that and stop.
You can click on the same green icon that you started screen sharing with, and it will stop.
All right. I think you stopped. I don't know.
Yeah, it did.
It didn't.
It didn't.
Just remember, whenever you present,
I am presented
of the moon, that you need to tell us the day and the time, so that one can determine when the picture was taken with respect to sunset or sunrise. Because just telling us the time tells us nothing, because like I said, here in the northern hemisphere, the length of day changes from 8 hours in the wintertime to 16 hours in the summertime.
Hey, Seek and Find, do you know Sandra? Or because if you don't, I can get the information for you. I know her.
You talking about as far as where she was located and all that?
Yeah, no, I can get a hold of her. I know her. I can ask her for you if you can't.
That's fine. That's like I said, I don't know where she was at. I'm just saying. I see the timestamps. 2:30 in the middle of the afternoon. It's not during sunset. Sunrise.
Oh, no, I'm just trying to let you know that I'm willing to help. I'm here to help.
Again, the time doesn't mean anything until you tell us what day of the year it is.
And what latitude she's on.
Summer or winter.
If those two said. They're smart.
I like that. Yeah.
Dean, the green button.
There's three. I have three geniuses on the panel. Dean listens very well, and that's why he does the modeling. And I meant the computer stuff too.
I don't think this question can be answered more thoroughly.
Yep. That's what I was trying to say.
If you want to say that, but the angles that he was showing were during sunset or sunrise kind of.
The angles that he was. I think
you get me her latitude and get me the date, and I will show you the exact thing that she was supposed to see.
Hey, what was the date of that that upload? I'll find out right now.
Well, I had two. One was 28th of May.
Okay, don't say anything else. I'll forget.
And it's Northern Hemisphere, U.S. or Canada, I'm guessing.
Yes, because I know it snows where she's at.
Seek and Find, this whole idea of the sun is really a fiction, because I can go out in the lake and take a picture at 9:30 at night, at 9:30, and see it perfectly like daylight. Why is that at 9:30? It should be night, shouldn't not?
Say it again.
I can go outside 9:30 tonight and take a picture of a buoy sitting out on the lake and see it perfectly fine, but it's 9:30 at nighttime. Why is that? The sun's got to be a fiction. Shouldn't the sun have disappeared a long time ago?
I don't understand the nature. I don't understand the nature of your question.
This is what you're telling us. You're not giving me the day or the time of the year in which these photographs are taken.
Oh, okay.
Now, if I go out under the lake in the wintertime and try to do the same thing, it's going to be in the dead of nighttime. I won't see a damn thing out there. But this time of year, I can go out there and I can see it just fine.
Okay. Fair enough. But before in the chat, you were like, yes, gibbous moon is a nighttime moon. Yes.
I said gibbous. You got to talk about waxing gibbous or waning gibbous. Different gibbuses.
So,
a waxing gibbous can be seen during the.
You can see both of them.
And the waning gibbous can be seen during the nighttime.
No, you can see both of them at both daytime and nighttime.
One is longer than the other.
You will see one in the morning and one in the evening.
Yes, exactly.
What about 2:30?
2:30 is afternoon. If she's far enough north, and if it's summer, she will be able to see whichever one it is for the evening.
She had this perfect angle to see it at that certain time. Because normally the gibbous would be at nighttime, right? Normally.
No, depends on which gibbous you're talking about.
You can call it a nighttime moon because at midnight on the equator, it is possible to see it straight up, right? Only it's all there. Where it would predominantly be? Would it be predominantly during the day, predominantly during the night for the ideal conditions? Right. That's why your diagram is kind of misleading about what it means to be a daytime or a nighttime moon. It doesn't mean, the sun went down, therefore the moon should not be there, nor does it mean we're never going to see it. It's where its zenith is.
And plus, it depends. Look at where you're getting mixed up with gibbous. It depends upon whether
he's going to make a point, and then you're going to make a point right after him, George. Let me respond. It
depends upon whether or not you're talking about the gibbous moon that's occurring before full moon or after full moon.
The reason for a new moon is what?
There's two gibbous moons. There's one before full moon and one after full moon. One of them you'll see predominantly in the day. The other you'll see predominantly.
No, George. One of them you will see predominantly in the morning, and one of them you will see predominantly in the evening during the day. But you will equally have.
Okay, I mean, you're splitting hairs. I'm saying, versus night and dark, or night and light, nighttime versus daytime.
Wait. The crucial point for daytime, nighttime moon is where its zenith is. Like when it's directly up ahead for a gibbous moon and the full moon, it will always be over. Its zenith will always be over the night side. And for
okay, you're getting into a little more detail there than I was trying to. But yes, you're correct.
So Barney,
there is no difference between waning and what's the other word? For how much you can waxing, how much you can see during the day. That difference will only be where you will see it in the morning or in the evening.
Okay, right. So Barney, you agree that gibbous moons are predominantly nighttime sky observed moons, correct?
Yes.
It's kind of like to get a crescent moon in the nighttime sky, you got to be at this like exact angle, peeking around.
It will be less predominantly. It will be rarer to see it.
Yeah, but going from the
that's what the word predominantly means.
So my question is, in the nighttime sky, you get full moon, gibbous moons, and maybe a half moon first, or whatever the other one is, half moons. But to get a crescent moon in the nighttime sky would be kind of bizarre, right?
You can't have it
bizarre, right?
Nighttime. You can have it shortly after sunset. What the thing is, your understanding, you can see a gibbous moon during the day, you can see a gibbous moon during the night. We're done. We've answered your question.
Look, if you have a six-sided die, it would predominantly not come up 6. But that does not mean that when you see a 6, you need to go, oh, fuck!
So if y'all just picture that crescent moon that I had up, I don't know if I'm still sharing or not, but the crescent moon, it's...
But why are you doing this? We've already answered your question.
All right, never mind.
You can see a crescent moon at night shortly after sunset. We've demonstrated that, and you've understood it. You understand that you can see a gibbous moon during the day. You can also see a gibbous moon during the night. So we're done. We've answered.
Yeah, let us know when you see the bat signal on the moon. Then we'll talk.
Yeah, there you go.
The reason crescent moons is because
he's been coming up with this,
the angle of the sun. That's the reason for a crescent moon, is because of its angle to the sun, and it's a daytime predominant moon. To see it in the middle of the night will be a contradiction to the model.
No, it wouldn't.
You don't see it in the middle of the night. You never see a crescent moon in the middle of the night.
I just showed you one.
No, you didn't. You said it was at 9 o'clock. We don't know at what time of the year, at what point in the year that was. I can't see a crescent moon at 9 o'clock this time of day or this time of year because the sun is still up.
Right, because it's a daytime moon.
Oh, God.
If you're standing on the North Pole in the middle of the summer, you can see all of the phases of the moon depending on how the orbit of the moon is tilted towards the Earth. There is no problem there. The problem is only when can you see it at zenith? When can you see it directly overhead? When can you see it at its highest point on the sky? And that's what defines whether it's a daytime moon or a nighttime moon. And that also defines how much time that moon will spend in the sky during the day or during the night. So you will predominantly see a nighttime moon during the night. And I love you using that word because that's the exact word that you should be using. And then you're saying, well, that's a contradiction if we ever see one. No, it's not.
Yeah, but Barney, the reason for a crescent moon is because of the sun rays. It's because of the sun rays. And
yes.
Right. And this right here is showing y'all that I don't know if I'm still screen sharing. Am I still screen sharing?
You're not.
Well, in the diagram, it's showing the daytime. In the daytime, the whole reason for a new moon is because of sun rays. So the reason for the crescent moons is because of sun rays, right?
Yes.
All right. So for an observer that's not getting no sun rays right now, we're on the dark side or shaded side of the Earth at night. If the moon is in my sky at night, the angle that it has with the sun is going to be showing full gibbous first quarter or last quarter. If it's in my nighttime sky, that's the point. Yeah. Okay. So seeing a waning crescent or a waxing crescent in the middle of the night.
What part of Dean's demonstration did you get? God.
Okay. On your diagram. So you can find once again. On your diagram, right? If I look at a point which is on the circumference of this Earth, like on the equator, and if I draw a line, I can see more. However, it's a sphere, and from here up north, I can see so much more during the night towards the horizon. I can see so much more, right? Do you get that? It's not going to be in zenith. It's not going to be directly above you. It's going to be nearer to the horizon.
I figured it out.
You can see it at midnight, at dead midnight. You can see a crescent moon. You cannot see a full moon at daytime unless you're sufficiently far north that you get those really long days. And it's kind of like saying you can't see the sun at 11 p.m. because it's nighttime, right? But no, 11 p.m. is not nighttime when you go far up north. You can see the sun at midnight from the North Pole. Same thing goes for the moon. Same thing goes for the nighttime moon.
You don't think you see it from this orientation, right? You realize that you're on Earth. Maybe that's why. I'm just guessing.
I'm trying to let y'all move on. I'll just move on to the next point.
I don't know. Next point. Go
on. Seek and find. Can you see the sun at midnight from any point on the Earth? At that local midnight for that point?
Depends on your location, I guess. You're talking about in the heliocentric model. I guess it would depend on your location.
No, I'm talking about actual reality.
Can anybody see? Say it again.
Can you see the sun at midnight from any point on the Earth?
Oh no. The sun?
No.
Just explain.
You really need to talk to some Canadians, Norwegians, and Alaskans.
Yep.
He literally just explained to you that that's exactly what happens. He explained that.
Shows how much attention he was paying.
Right? During the summer, those areas get 24-hour sunlight. They have the sun up in the sky for 24 hours.
In the north?
Yes. And in the south.
The north, maybe. I don't know about the south.
Exactly.
Not too sure.
How are they seeing the sun at midnight? Shouldn't midnight be the dead of night? It's the same effect with the waning and with the crescent and gibbous moon. The same exact effect. If you go up north, you will see it for longer, you will see it for more, and you will eventually see it at midnight if you go far enough north.
Okay, I'll model it again, but like I said, I played around with stellarium, and every single time the moon was on the dark side of the Earth, it was in gibbous or full phases, or quarter phases, but never.
Yes, because that's what they will predominantly be. If you take an accurate model of the Earth-Moon system, which actually shows their actual positions and put in the right date and the right time, yes, you'll get it. But Dean has been approximating it really well and has shown you that you can see it from London at a very, very drastic crescent moon at night.
All right, guys, I'm going to drop. I had some questions, but you guys can talk forever and ever and ever and ever. Peace out.
We can. Yeah, apparently that's what it takes.
Yeah, I mean, it just seems like whatever we say, you guys are going to say this or that. So, I mean,
well, that's
look. When I say level, hold on. When I say level water is flat on the surface, if gravity is a force and it's doing anything to still bodies of water, it's making them flat on the surface.
I have you saying that exact phrase in question probably 43 times.
Okay.
Do you see a problem with that?
Track, dude. On that shit.
I'm trying.
Well, the physics of water, pretty much destroyed the globe. So.
No.
The audience is saying they can't hear you, Sean.
I mean, this coming from the guy that can't understand phases of the moon. Yeah, I mean, this is coming from the guy that can't understand.
So George, you agree that water shows the effect of forces acting upon it? You agree?
Word salad. Say it correctly.
Water shows the effects of forces when they are acting upon it. Yes or no?
Oh, you mean like wind?
Does, yeah. Even inertial forces. How about that?
Yes. Everything shows the effects of forces when they act upon it. That is the definition of forces.
So this force, what is it doing to still bodies of water?
What force?
The force of gravity. You guys said it's a force, right?
It is keeping them stuck to the surface of the Earth.
So the water would be flinging off, and gravity is counteracting that force and making it level, aka flat on the surface.
Nope, don't say flat.
Yeah, in a sense.
No, we don't like flat here.
Level on the surface, yes.
I don't know if it would be flinging off. It might just float away.
Or just fall off.
If it's a spinning ball,
it won't be flinging off. I mean, the thing is that the centrifugal force is about 1/300th of the gravitational.
I don't bring up fractions, George. There's no place for fractions.
If there was no gravity, yes, it would be flinging off. If there was no gravity, the Earth would not be a sphere.
Yeah.
There would be
with gravity and with the Earth rotating once every 24 hours roughly, the centrifugal force that tends to want to make the water fling off the Earth is only 1/300th of the force of gravity onto the surface.
So perfect. You guys, I don't know that y'all realize, because I know most of y'all are probably atheists. I know I talked to Barney and I talked to Sean about it. Yeah, that's what
they say about
this discussion is really about. It's really about the creator. I don't know if y'all understand that, but yeah. This is not about the shape of the Earth. It's about.
So for some people, apparently it is. Let's say for Sean, it wasn't.
It's a lot of perfect shit going on, and no, you know what I'm saying? It's a lot of things that are just coming together so perfectly. For us
I know, right? Ain't that a fucking trip?
Yeah, man, it's amazing.
Crazy. It's crazy how shit works.
Yeah, it's amazing. The creator's awesome.
Hey, creator, no creator, man. It's still a fucking globe.
Yep. Yeah, that's fine, but the globe takes a creator. No, I'm saying in your mind, that's fine. Awesome. It could be a globe to you, but your globe takes a creator. That's
not a globe to me.
Okay.
Wait. Are you saying that yours doesn't?
They both do. Both models take a creator. In my eyes,
you kind of sound like mine.
The more I dig into science and mathematics, the less I find the necessity of having a creator.
Yeah.
Sean, why did you go and start this stream right when Sean was going to start his stream?
I'm going to let you guys know right now, I stream at the same fucking time every day. And I put my link out in Jose's chat before you did, Sean. What? And it was before yours. Word.
That's some serious antisocial behavior, Sean Hawkins. Just FYI, heads up and all that shit, dude. You don't want to alienate yourself.
Hey, man, you may be angry, but I get triggered better, so. Relax your pantyhose, man. I got the timer's already on. I already turned the timer on. You can't be mad at me. I already have my timer on. Timer to end the stream. Continue on.
Can I do impressions? Chris will tell you the minute I start one, someone else is going to start one and take all the viewers. I'm fucking finished.
Ow.
What the hell just happened?
I don't know, but my ears were pierced.
Can't stand it.
All right, guys. Thanks for having me.
Just wanted to address one thing. You said whenever you bring something up, we talk your ears off. So from my point of view,
I didn't say that.
I sincerely try to convey my understanding of these things to you, right?
Yeah,
when
Barney, I got no problem.
I will tell you why I think it is so and what I think about it. And I would really appreciate it if you would kick back, if you would give me your understanding. What is your understanding of why she was able to see the waning or the gibbous moon? What is your model, right? How does the Earth look, and how do the moon and the sun move around the Earth to enable her to see the gibbous moon at 2 p.m.?
Okay, but before he does that, I will be presenting how unicorn shit can be turned into gold and make you fly.
Yeah, I mean, if you're asking for a model, I don't have a model, obviously.
I know you don't. But
so then why do you deny the heliocentric system? I mean, if you don't have a model to replace it.
It wouldn't be because other people said so.
You have an understanding. You have an idea in your head. I'm sure that idea makes sense to you. I would like to understand that idea. When you contest with the gibbous moon against the globe, there must be some idea in your head of what you're looking at.
Well, I just don't think the moon is a sphere reflecting light, because for every observer to be getting the same, this is what made me start looking into the moon. It's like for every observer to get the same phase of the moon, and these angles on a sphere of it reflecting light just don't add up to me in my head. And like when I see the moon,
see exactly the same thing. Not everybody on the Earth sees the same thing. People at Southern Hemisphere see something a little different than the equator. It's a small percentage, but there are changes.
And I was saying also that I've seen the moon like all day in my sky before. Y'all say it's impossible. I've seen it though. I know what I've seen, and I just got to thinking like, why am I not seeing this phase? It's a sphere up there reflecting light. I got hours to look at this thing, and it's really not changing phase. Maybe I need to get me a camera and zoom in on it a little bit more. But
just really quickly with what you just said there, so you can find. I'm just going to share my screen again because I built a model that accurately represents the distance between the sun, between the moon and the Earth, of 250,000 miles or thereabouts. So it's like looking at the back of a bus or a car, but that car is 50 miles away, and you and your friends are spread out over the course of half a mile wide. Now, the ones at the very edges might just be able to see down each side, but only just, and let's say about, give or take, 4 or 5 degrees, they might be able to see it, but it's just so far away, and people don't understand the distances involved. So right here on my screen right now, we've got the Earth with a lovely cloud layer, and then we've got the moon all the way over here. And this is accurate distances. So the problem is, if you look at the angle from being in the top hemisphere or the left and right adjacent to the viewing angle of the moon, have a look at the very, very acute angles that are here. And they match and purport to reality of if you took a photo simultaneously from, let's say, Africa or Argentina, you'll see a very slight, I think it might be 4-degree difference in the view of the moon. And it is because of the distance here and this very acute angle, which is, I don't know, I'm guessing 4 degrees. And this does actually match with reality and observations. The moon is just a long way away.
okay, so like for here, hold on, you're changing it around still. Like, why don't you just leave?
Sorry, I just realised that I'd got the moon backwards. All the meteors hit on this side.
Well, we can't have that.
Yeah, I know, right? That's terrible. Sorry, yes, I'm over here on the Earth again with a 23-degree tilt.
Sorry, it's not above 720p. It confuses him.
I know. Yeah, people are asking me questions. They can't see this, Sean, because of the crappy resolution that we've got. So yeah.
Or maybe it's just I haven't been at the computer to share it.
Yeah, so like so the moon right now is in like gibbous phase. For somebody that's in the daytime, for them to see that, it's going to be during like sunset hours or those peaking hours. That was my point. For somebody like, hold on. For somebody like that's in, say, I guess that's Australia or something right there. They're the ones that's in like 2:30. You know what I'm saying? 2:30 in the middle of the day, and they can't even get eyes on the moon from right there.
How do you know?
Yes. And half of the world cannot set eyes on the moon.
Right. That's part of what I'm talking about.
It just, again, it depends on the time of year and your latitude and the time of day.
All right. So it is not something that you see.
It depends whether the Earth is tilted towards the sun or away from the sun.
It's something that I'm just saying, your answer is something, it does happen, but it doesn't happen all the time, right?
It doesn't happen all the time. It does happen. It doesn't happen all the time.
Thank you for your answer, Barney.
That's like, okay. That's what science has been telling you. Barney just told you this time.
Every month, the sun is at a different altitude above the horizon. at your location.
2:30 in the middle of the day. That's what you would call like an anomaly there, but.
No, it's not an anomaly. It just, again, you haven't
call
told
it
us
an anomaly. You'd have to
year.
track all the cycles of the moon for an entire year to find out if it's an anomaly or if it fits right in with the trajectory of the moon all along. You don't know what the moon is doing because you haven't worked out all the paths of the cycles of the moon and the sun. So when you call it an anomaly, it's because you have no freaking clue, none whatsoever. Well, after you go and you do a whole moon, you know where the moon's going to be every minute of every day for an entire year, then you can tell us what an anomaly is.
All right. Well,
hey, look, I run a Kudo club, and we have training every Saturday. That means that on an average day, I'm not going training, but every Saturday I go training. It's not an anomaly that I go training, even though I don't do it every day, right? It happens regularly. I can predict when it's going to happen. Right? And the model is accurate enough that we can predict at what time, from which point of the Earth, you're going to see which phase of the moon, from how many hours in the morning to how many hours in the evening, right? When it's going to come up and when it's going to set, which phase it's going to be in, all of those things. That's been modeled for Jesus amounts of time.
Since Jesus.
Jesus.
All right, guys.
Most of us aren't really fascinated or impressed by the things the moon are doing anymore.
So that moon, as it keeps traversing right there, it would be turning into a new moon, right? So this moon's going to go from this right here to a crescent to a new moon as it keeps going.
Hey, Barney, I was just kind of wondering, this time scale, Jesus, is that a substitute for AD or current era?
No comment.
Yeah, current era, GE, GL, GL, Jesus.
Well, I'm out of here. Thanks for having me, Sean.
Yep. Yeah, guys, anybody want to do their final words? I don't think I'm gonna let Stingray do it today because I'm not impressed with his 720p graphics. Not impressive. You're not really fitting in with the level of intelligence we have on the panel.
What with the amount of pixels that I'm shoving out? You're judging me based on the amount of pixels that I'm shoving out.
My eyes can't adjust. My eyes are all cross-eyed.
How many tabs do you have open?
I have 1, 2, 3, 4, 5.
I have 7.
Oh boy, we got low IQs in here today.
So I have. Wait a minute. I have this stream with the chat. I have this hangout. I have 2 development boards, and I have angles to the angles that I wanted to set the moon. I wanted this so that next time someone asks me, this is a 23-degree tilt, and I can place them on the globe and set the times and everything. So
let it keep playing, and for that observer right there, it would go from.
No, we're gonna let Dean fix it because Dean needs time.
Yeah.
Everybody go and subscribe to Dean's channel so you can see this shit in 1440 instead of 720.
Whoa! He's in 20. He's in 20. He's in 27,000K, guys.
No, I mean
it's so real.
Firework and shit.
Yeah, your computer needs an IV to work. Just so you understand, it has to live. Got your back, dude.
On his screen, this is actually a 1-to-1 model.
I don't know what that means.
The Earth is the actual size of the Earth, and
yeah. He actually uses the Earth. It's in universe. It's in universe K.
His computer monitor is currently on Mars. He's using a telescope to view it.
Yeah, exactly. He's got a monitor on each planet.
I'm feeling not very welcome here. I'm going to go.
This is love, Dean. Can't you tell love?
This is very harsh love. I'm afraid. I'm gonna...
Can you stop presenting? Because
crap! Yeah.
Because we're like feel for you, and then we see it, and you're like, ah. So, anybody want to say their last buys? I know a couple of you guys didn't get to talk. I apologize. Happens. I gotta.
Right. Oh, Barn. Oh, I'm sorry. Go ahead.
Yeah, no.
I was just going to say to Barney, I see a mistake, or not a mistake, but something we've neglected to point in on this phases of the moon, on this diagram that Seek and Find gave us, is that if you look down on this 2D diagram at the waxing gibbous that we can see on the daytime side of the moon, or of the Earth, we should have also noted that the Earth turns counterclockwise in that diagram. So more and more of the daytime Earth sees that waxing gibbous as the day progresses.
Wait. So let me get this straight. Yeah, no, stop. Hang on.
That's what I meant by you see it in the morning or in the evening.
Hang on, guys. Hang on. Let me
it's
get this
around
straight.
sunset or sunrise hours that you
Let
might
me
get
get this straight.
I agree with that.
Hang on.
But in the middle of the day,
George and Barney didn't tell you the 100% of everything they were supposed to. Fuck, it's flat. Thanks, guys. Thanks. Rumpus, thank you.
You're welcome.
Yeah. I've come to.
You're right. I give up. It's flat. Fair enough.
If my God says it's flat, then it's flat.
You guys are weak.
Wait,
Yeah,
is
what
it
does
flat?
Q say?
I'm not weak.
Is that Q?
No,
I'm mushy.
What's up?
You and Barney are my gods. So if you guys conflict, there's a problem. Sorry, Barney, you're dead. Wait, but Barney's got that lighter.
It's ironically flat.
Yeah, see, my gods agree. We're all good. See, perfect. Farmers, you ain't said shit.
I've not really had the chance, to be honest.
Yeah, it was one of those streams. Yeah.
It's been a case of just sit back and let them get the hell on with it.
Hey,
yeah.
I'm not gonna lie, I was all in the beginning, and I just sat back and.
Yep. Yep.
And,
I
just been enjoying.
That's what I was doing wrong. I don't smoke. Shit.
Yeah, there you go. Because I've enjoyed this whole stream. I've been in the background, but I've enjoyed every freaking thing.
What are the chances that this phases of the moon is going to rear its ugly head again?
Oh, very soon.
Tomorrow.
Yeah.
Tomorrow.
No. Seek and Find. He's repeat and repeat. That's what he does. That whole gravity talk. We've had
kind of
that
like
gravity.
chemo, huh?
100%.
A bit like chemo.
Yeah, no, but he won't go anywhere near like that. He's not. He doesn't go that far into crap. Just keeps asking the same questions over and over again.
Yeah.
Seek and Find. If Sean won't let you talk about this anymore, you can come over to my channel or have me come over to your channel, and we can talk about this as long as you have questions to clear up.
Oh, no,
Boy, you're a glutton for punishment, man.
You can come here anytime and ask me, Barney. Anytime, but yes,
no.
Guys,
I'm talking about the moon. I'm talking about the waxing, waning, gibbous, crescent moon.
I don't mind at all. But I mean, shit. Barney has a channel. Seek and Find has a channel. Motherfuckers, go sub to that shit because guess what? One day I'm gonna say I don't want to hear that shit anymore, and Barney's gonna be like, I do, and he'll live stream over there. And then, don't worry, Sean Hawkins. I haven't forgotten about you, buddy.
That's what Pete did after you threw him out. He went and live streamed on his.
I hope so. I hope that's
like 16 people.
That's exactly what the fuck you're supposed to do. That's why I live stream. I got sick of not having my live stream, so I started live streaming my live stream. And we'll get into it now. Fuck it. Sean Hawkins, my friend. I've been streaming for about 2.5 years, and I've made it a pretty good policy to not step on toes. Matter of fact, I've jumped through many of hoops to make sure I don't do that. Channel Q, I'm pretty sure you can vouch for me that I try to make sure I don't fuck anybody when coming into live streams. I kind of grew up in this whole little thing, knowing there's other people trying to do this too. But Sean, I live stream at 12 or sometimes one, every day.
Pretty much.
And whether or not you put your link in that chat after I had, or whether or not you saw it or not, understand something, Sean. I don't live stream based on what you're doing. It didn't need to be that way, but I sure as hell don't need someone talking about how I screwed them. John, don't do that, because I'm not even gonna get into it. But you should know what I was gonna say. But don't fucking do that shit. Don't come over here crying because you don't get a chance. You don't talk because you're not on your fucking channel. You feel like you need to talk. Go to your channel, dude. Everyone has the capability of getting a channel. All you gotta do is fire it up. I'll fucking even tell everyone you're doing it. But
well,
the difference,
saying you steal his viewers because you're live, which I think is bullshit.
I steal his viewers. Sean Hawkins, you welcome. Okay,
Said
just
it
put
about
it that
Jose.
way.
It wasn't just you; it was you and Jose that he included in that comment.
Yeah. Understand something, Sean, and it doesn't need to be that way. But you're welcome.
It's like yesterday. Remember yesterday I was in here? Was it yesterday? No, it was whatever day I did that stupid Katy Perry thing that I was doing. Right.
Okay.
And that's all like tongue in cheek. Don't be thinking I went insane or anything. Come on, people. But here's the thing. You were live streaming. I was in here and I went and did my live stream real quick and came back. And it wasn't like, I didn't try to pull any of your viewers over to it. I didn't even mention it. I just went and did my live stream and came back. And I was like, oh, I'm back. I had to do a quick live stream.
And even better than
that's
that,
my life. That's my life. This is your life.
And even better than that,
we're like
I've
out on the block.
I've given everyone permission. Oh, numerous times. I don't even need to say it. If you ever wanted to put your link in the stream while I'm please do. Why? Because sometimes we're talking about some shit no one wants to listen to, but at least they have an opportunity to go listen to somebody else. And if there's a group of people here that want to listen to you, they now know you're on. You can do that. Sean, you could have put your link in my chat over and over again. I don't stop people from going anywhere. I don't make them do anything.
Probably would have just jumped back and forth the whole time.
And that's what a lot of people do.
Yeah. Because like this flat Earth scene used to be referred to as the new pub crawl.
Yeah,
so people used to like it when there were a lot of different flat Earth streams going on at once, and they could just do like a pub crawl through all the flat Earth streams. So like, Sean, seriously, dude, this is an attitude that is your problem, and it's not anybody else's fault that you feel this way, but your own, because you're choosing to perceive this situation as though somebody owes you or is taking or is threatening you, and it's not that way at all. Everybody's just doing what they do, and you just need more confidence, man.
And the worst part is you got to understand, there's 100 other live streams going on right now. Are they supposed to not stream because you want to? That's what you got to realize. and I don't stream, and I've been going I'm on 3 hours right now. I average 3 to 4 hours. That's what I average. Sometimes it's shorter, sometimes I've gone longer, but it's whenever the conversation goes to. Like, I'm not going to just stop it because fuck that. I don't have to do shit. But this way, Jose goes on when Nathan goes on. Should Nathan go cry and be like, Jose, you're stealing my people? No, fuck that. What? No, now they have just 2 platforms for the same thing. I mean, one's really biased, but it's still there. Don't cry though, man. You're still, keep it real. You are still a newbie.
It's like freedom.
You just got here, motherfucker. Everybody. Damn.
So if we want freedom, it's going to have to be like 1 million live streams at once, guys. And if there's true freedom, there will be.
Yeah. And like Channel Q said, she decided she wanted to go live, do her thing. She went live and came back. That's what happens. And then when everything flows perfectly, we get the opportunities like, hey, I'm live, and then Channel Q happens to want to go live at a certain time, and I'm kind of done, and that worked out perfect. Now it's her turn. Like, that is a perfect world, but it doesn't really work that way.
Yeah, that's usually the best way. Like, just pick up somebody's stream when they end it, and then there you go. Then you're live streaming. You've already got like a bunch of people who are ready to be on a live stream and watch a live stream. But I didn't really care about that thing I did the other day because it was so off topic to Flat Earth. I didn't even plug it, because I was just being goofy in my own little mind. My own little creative mind comes up with these weird things.
Matter of fact, hey, Sean, I have a good idea for you, buddy. And I don't know why you're not seeing this.
And Jem's Sunday Roast is currently live, guys. I just, I don't know if that's going to steal all your viewers.
No. I'm leaving. No, I'm leaving because I actually enjoy that. YouTube channel, Debate Fly Earth and More. What's called? I was going to say, fuck. Oh, Sean Hawkins. Why don't you go live after Jose? I always span 2 hours out of it. I always have a long break between Jose. Why don't you stream there? I know you're trying to find your little niche, but the last way you're going to get a niche is pissing people off. Don't do that.
Nobody owes you nothing, dude.
Yeah, trust me. Angry Sean Hawkins means I don't care about. It's a globe, dude. We don't even need to talk. You see what I'm saying? Like, don't burn bridges. And crying burns bridges.
Screw you guys. If I have something to stream about and have people to stream about with, I'm going to stream it.
Please do, Barney. Please do. And then I will just come watch it when I have time.
Exactly.
Because what I'm going to do right now is I'm going to end this stream, and then I'm going to go search Flat Earth Live, and I'm going to go yell at every single channel that's on right now.
GeoScriber's fucking live right now, fuck.
Yeah, what the fuck? And I went live before all of them.
Cigarettes went live too.
Oh, bastards. Yeah, but no one watches him now.
He's 167 mofos in there. What do you mean? He's got like 167 mofos.
Of all the people, I have no room to talk. Trust me. I thank Jose. Jose got me a lot of people here. A shit ton. Those opportunities to do that shit in the morning. Jose, thank you. See, that's gratitude.
Hola, Jose.
Yeah,
I'm probably gonna go live tomorrow, guys, at 5 p.m. Eastern time, just for an open hang. If anybody wants to drop by, I am not allowing Pete Shea in because he's had enough airtime lately.
Yeah, he's done. He's gonna be done for here for a little.
It'll be a Pete Shea free show. I'd like to get some other conversation going, and also, Dean, I just want to let you know, dude, I don't got nothing against you. I like you, dude. I just like picking on you for being so privileged.
Don't let her lie to you, man. Your 720p concepts they're lacking.
Check your privilege, man.
Yeah.
In 4K.
Okay. Yeah. Anyway, Sean, stick around at the end because I need a chat.
Fine.
Yeah.
That means you gotta be quiet. You do that, Dean?
A little bit. I'm going on mute.
Play with your little models.
Yeah, I'm gonna go because I'm gonna go check out Gems because they're live now.
Yeah, I'm gonna end it and then get over there as soon as I can. I'll see you guys over there.
Cool. See you guys around and tomorrow.
Yeah, thank you guys for being on. And if I go on, I'll make sure you get that link over to me for your stream, and Sean Hawkins, fuck you. Oh man,
Sean, what are we talking about now?
Talking about ending this damn live stream.
I'm just messing with you, Sean. Good stream.
The timer ran out like 20 minutes ago.
Oh, I know. I've been looking at it and staring at it. And I just don't like being an asshole. And I wanted to say something about Sean Hawkins because that shit pissed me off. And I don't like acting like this, but motherfucker, it took me a long time to get here. You're still catching up. Okay, asshole. I can be an asshole too.
Shanji, next time, we're going to talk about lemmas, about theorems, about theories, about hypotheses, about all of those terms, right?
Oh, yes. I've never really did it.
Did he get to any of them?
So does that mean you're going to have Quantum Eraser as a guest speaker?
I would fucking love for him to come on here. I'd have flying crayons in the background. That pussy would never come here. He'll never come. I'm still blocked in that damn server. He put me in some little room, and I haven't been out in a month. That hurts my feelings. Means I know I'm doing something right. But then again, I did ask him if all his little what do you call it? Like if you go to his server and you ask him a question, he has like things to share already prepared, and he just throws these paragraphs at you. And I said, do you have those pre-scripted so you don't have to remember them? And he put me in that little room.
Yeah, and not only that, they're color-coded.
Yeah.
Oh, yeah.
That is so awkward. It's like, dude, that's a fucking mighty fine script you got there. I'm so not reading through all this.
It'd be amusing to get him on a one-on-one without his cutty pasties, just to see how he would do on his feet on his own.
Personally,
is anybody selling color coded, flat earth flashcards yet? I mean, it's gonna happen.
Is what?
Color coded flat earth flashcards. You just give them the flashcards. So
flashcards. Okay, sure.
Patent pending. How that works.
Wait a minute, didn't someone mention that you can play bingo with? I know you told me to be quiet, Sean, but I can't. Did you? You can play bingo with cards, can't you? And just see when you get a flat earther on, you all have these bingo cards, and they're just all the random sayings, so we can see who gets bingo first.
Every time you talk, Dean. Every time you talk, my viewers drop like 10. No, like you talk, they drop 10, and then you stop talking, it goes back up. It's weird.
Yeah, well, you wanting to end the stream? I'm helping you.
What?
Look at my screen. You'll see it.
Holy shit! There's 40 people watching this.
Damn! Thanks, Barney. It was 50 like half hour ago.
Hey, Sean, maybe you can start a takeoff on Family Feud. We could have Shape of the Earth feud. Number one answer for another name for retard. Number one,
you know what?
Flat Earther.
I didn't think like that for a long time, but man, I'm starting to become an asshole. And I'm embracing it.
It happens after a while. Dean hasn't crossed that threshold yet. He's much too nice to flat earthers yet.
I'm not sure if you heard my intro outro, but it's different. and I'm serious, flat Earth. But being pussies and debating.
You get cynical after a while listening to the same stuff over and over.
And Dean's a little upset. I'm not sure if you heard. Have a second, guys. Just one.
My little upset. I don't know what this is. I don't get upset.
Dean, stop.
We'll give you time.
Okay.
Well, not very often.
No, but I'm not sure if a lot of people know, but my cherry was popped 2 days ago. I brought another one back.
Yes.
We got another Glober, guys.
Oh, right. I know where you're coming from now.
Bandsaw is a Glober now. So proud of it. And it happened to be Dean's favorite flat earther.
Yeah. What put him over the threshold?
It was a good thing. We're I had a hangout, and I don't know, I forget who decided. I think it was he decided. Someone decided. You ask us, farmers. I think you were there. You ask us the questions, the ones that like have you questioning whether or not you want to go over to the other side. And
Cruising with Jay promised that he will send us each a beer.
Yes.
If we can turn him Glober by the end of the stream.
That too.
If we can turn Bandsaw, that's how it started.
Yep. And it worked. He's a Glober now. He even went off on chemo spurs the next morning.
Barney? Somebody say Barney?
No. All right there, Barney.
I can hear that voice in the background.
Barney.
Yeah, there are voices in the background. Is that your kid, Sean?
Oh yeah, that's my boy. He knows I'm streaming, and he promised me he wasn't gonna talk. Then he got his headphones on and decided he didn't give a fuck. He was gonna talk.
Yep, sounds about right.
Yep. It's all good though, because I have in the works. I'm going to build a studio in my garage. Excited. Oh man, this is going big. I got Dean. I gotta talk to you, man. You guys stay here. I'll be right back. Let me end this damn thing. Okay. All right, guys. I appreciate. See, the second I started, you guys can't hear it, but the second I left, he starts talking. Instantly started talking. He can't help himself. Dean is just. He's a special kind of guy. Let me do this real quick because I can't do this. All right. Now I can hear. Perfect. Okay, so guys, I appreciate you guys being here. Again, it's definitely like I said a lot of stuff that it is exactly how it works. It took it took a long time to get to where I'm at now and be comfortable on live stream with confidence that I have people here the whole nine. I mean that shit takes time, not overnight, and sure as hell not going to be taken for granted. When somebody is crying about their airtime, again, I mean we're not getting paid to do this, dude. I'm not here to make sure Sean Hawkins' channel gets big. I don't mind helping you. I don't mind fucking promoting your shit. I don't mind you promoting your shit in my chat. But I'm not sure if you noticed it or not, but there's no what are you gonna do for me when it comes to Jose, Channel Q, Crash. At the time I thought yourself, but if it's all about the airtime, Sean, go live any time you want, my friend. But don't come over here crying about your shit. Don't come over here crying. Don't come over here crying because you didn't get to talking to other people's panels. Just how it works. It took me 2.5 years, Sean, to get to where I'm at now. And I ain't shit. What magical world do you live in that crying about what time someone's going live matters? Because if you'd like me to, I can go back to Jose's channel and take a screenshot of my link before you put your link in there. So should I be mad that you fucking decided to go live an hour after I did? No. It don't work that way. Grow up. If you're angry Sean and this is what it is, go angry Sean somewhere the fuck else. I don't need that shit. Stop fucking crying. Grow the fuck up. We're all grown men.
A lot of you question whether or not I'm here for truth. Question if I was a real flat earther or not. The reality of it is there are no flat earthers. There are only globe deniers. Every flat earth evidence really is just a globe phenomenon. Explained by the globe. Don't you see? See, I'm still here for truth. And now there are certain people in my way.